questions related to
Sure.
yesterday training.
Yeah.
Because I have something when I played with the iteration of the lists, like cars and brands. I think that if I, let's say, want to find some item in the list,
Yeah.
and it is a high complexity because I have to iterate through all the elements.
Okay.
Do you think that it is efficient to use map instead of list?
Yeah, definitely. So this is one point we are working on today,
Okay.
because maps are much more efficient in certain ways, as I said, and especially when you use lazy loading, you have to use maps for better performance instead of using lists. And yeah, that's a topic for today, I would say.
Oh, okay, so I will wait for the for the topic. And the next question, when I, for example, change some item in the data model, which is referenced by other items, and go back to the document root. Should I store the item itself or the whole document root? If I change only the one item in somewhere in the deep.
You store only the item itself which has changed.
Yes.
Yeah, not the whole item. Yeah. It depends a little bit on, so you have to store the whole object. That's for sure. But so for example, if you have one item with many child items, and you change only one field of the main item, I would say, then and you store you say store with the main item, only the main item will be stored, not all the child items again.
Okay, and so it's okay if I save only those items that are changed.
Yeah,
not the whole graph.
That's right. Yeah.
Okay, and if I, for example, don't store only the one object or the one child, but store the whole graph again, then if the whole graph will be stored again, or is there some heuristic that will discover changes or differences and store only those that are different?
That's also a good question. Normally, I would say only the objects will be stored with changes in it. So when you say, or when we say, okay, let's use an eager storer, for example, and the only way to store a whole graph completely is to use the eager storer. And I'm not sure if the eager storer stores also objects again without changes. I have to check that. Let me take a note for that. So then we can ask Florian maybe.
Because I have an idea that if I don't want to store every single object that is changed, then I can at the final, I can store only the document root, and it will store everything, the whole graph, and to simplify the thing. But I'm not sure if it's possible or not. Okay, and the last one, I played yesterday with the current brands, and I don't know what I'm doing wrong, but if I, for example, start the application, store some objects, if I restart the application, the data are not in the store reloaded, and I actually don't know what I'm doing wrong. It's possible to check it.
In which project is it?
Is the cars and brands. It's a MicroStream fundamental training. So I created a project from scratch.
Okay. Is that car exercise or?
Yes.
Okay. We do a review of that car exercise in the next few minutes then.
Okay, well, I will wait for it.
Maybe we can find, maybe we will find the problem then there. Okay, I noted the question eager regarding the eager store stuff. I will ask Florian for that.
Okay, thank you.
So let me just check if okay. So we have 13 participants. That's okay. Yeah, let's start on 15. And then let's have a review of the car exercise. Okay, so I think we can start. For those of you who joined later, welcome to the second round of the MicroStream fundamental training. Let's have a short look to the topics for today again. So we start with the review of the exercise of yesterday. So and after that we jump into the Java 8 Streams API. Let's go through all the different streams types and possibilities. Then a very interesting topic is lazy loading, also to use different data structures instead of lists or sets. So we talk about to use hash maps and so on, and what's the advantages in that case. Then we have legacy type mapping as huge or small topic, I would say. Let's talk about what happened when we change some classes and so on. Then let's go through the backup strategies. What strategies are in place at the moment and what can be used as a backup. And then some small best practice topics. Maybe we can have a look to an example how to write data to a MariaDB or PostgreSQL. We will see. It depends a little bit if the project is working or not. But yeah, I have to check this during the day. Let's go to the exercise. The exercise is available also on my GitHub account. There is a project which is called car exercise. Let me share the URL for that. That's the URL for the exercise. I already cloned it in my IDE. Oh, I have to change the resolution. Give me just a second. So. Okay, now it's better for you to see the code. Okay, so this is the car exercise, and you started it, and yeah, let's go through the project itself. Please stop me if you want to change, or if you have any questions to the exercise. I will start at the POM XML.
Christian,
Yeah.
may I stop you? How do you start a project? Do you take an empty Maven project, or how do you do it? Because I probably have done a wrong choice.
Okay.
At the very beginning, and when I could not, it didn't work as I expected.
So especially for Micronaut, I did it like this. I go to the Micronaut launch page. This one. Micronaut version, that's the same, Java 11. So I choose a name. Let's call it MN test, for example. I use Maven in that case, and then I say this is one.microstream JUnit, and that's all. Then I download the zip file, and after that, let's do it like that, and I unzip the file directly, or I copy this directly to the workspace. So let's do it like that. So show in System Explorer. This is my workspace here, fundamental training workspace, and there's the zip here, and I just unzip the project directly to
I get you. This is what I've done wrong. Yeah.
And then I import the project itself. So that means file import, and for the import I use the Maven project, and in that case I use an existing Maven project. Next, and I have to choose the test project, and this is what I'm doing, and how to create a project like this.
Yeah. Okay. Thanks.
Okay. So, but you, instead of that, just clone the car exercise. That's also possible. Then everything is also in place. Okay. Let's go through the POM XML. There are, just have a look to the storage embedded and storage embedded configuration. These are the two dependencies we need basically with MicroStream. Should be, it could be possible that only the configuration does the job also. I think that's also possible, to have only the embedded configuration will also work. Yeah, it seems so. But most of the time I have both in it. Yeah, that's okay. So, okay, POM XML. Then I created a few entities. I have the company entity, the car, and the brand. Let's have a short look. Company with a name in it, and as I can see, I used the company also as root object. So later, and within the company we have a list of brands, and we have a list of cars, and inside the car there is also again one brand field. So that means we have the brand, we have the brand both or two times in the Give me just a second. It's early in the morning, so
In the object
the
drafting.
language processor has to start, and that's sometimes that's not easy. Okay, so we have the cars 2 times in the graph. So and that's that should work. Okay, we talked about that yesterday. Okay. Car, yeah, the brand, nothing special. We just have the name field in it, and that's all we have. Okay, brand, car, company. These are the entities we have. Let's go to the DB class. In that case, I used the builder instead of the XML solution. The root, as I said, we use a company object as root object, and we have the embedded storage manager as static object in the DB class. And here's the instantiation of the storage manager. This is stuff we did it yesterday, so nothing special. The important thing is you have to set the root object, and yeah, we didn't set the storage directory in that case. Foundation, yeah, maybe we should do it we should say, okay, set storage directory data. Then we will get the data here within the project. Okay. Instantiation is in place. The entities are in place. Let's have a look to the brand controller first. Yeah. Okay, we have here a list of brands. And this one is different now because I used a post instead of get, but that's not that important for your project. If you used a get also, that's okay. In my case, I used a post now, and I also had a data transfer object brand within the body of the request. So let me check this. I think I used the postman for MicroStream training car exercise. Yeah, you can see that here. We talked about the brands. So this is the insert car at brand. This one is, and this is the call. As I said, it's a post call, brands and insert. It's this one, and we have raw JSON in the body, and this is the data transfer object, I would say, or that's the JSON file in that case. Just a name, and the name is Ford in that case. And okay, let's go through the business logic within the methods. That's the easiest one. Just return the list of brands. That's not important, but the interesting part comes here. So I use a stream, like we did many times yesterday. We stream through the brands. We filter the brand on the name, and if it's present, then we create the new brand, set the name, add the brand to the list of brands, and then we say storage manager store, and the storage manager stores the collection because the collection has changed. Then we return an OK, and that's all. You can double check this with your solution, what you created in the brand controller. If this is the same like you created yesterday, or is there something different? Maybe, yeah, we talked about there is a second solution to find an existing one. We used that any match method.
I would have one or two questions just to clarify. Because in the end, I didn't create an insert endpoint because, yeah, maybe I'm too German here, but it wasn't listed as a criteria in point 6. So I felt like that the brand should automatically be created if you create a car with a new brand.
Yeah.
And secondly, coming back to the setup of the MicroStream configuration,
okay,
we should have taken the XML configuration part.
Yeah,
right?
yes, you're right. But I told you when I explained the exercise, it's totally up to you. You can choose XML or builder pattern.
Okay.
That's not that important.
All right, thank you.
Okay.
I see one difference in the DB part where you created a document root directly from the company, but in my case, I created a data root and inside it the company.
Ah, okay. You create a second root. Did I understand that right?
Yes. I didn't use the company as a root, but
okay.
I create a second root. So maybe there is an issue with this.
Yeah, that's basically also, that's okay. I would say maybe, yeah, let's do that as an example. So let's say we have a non-technical root, for example. Let's call it data root. And then you have only one company object in it, right? So it's just one company. That's also okay to do it like this. I think it's up to you to create your data structure. Sometimes you will, maybe you have to some tenants or some clients or something like that. Then you have a list of companies maybe inside the data root. That is also fine. It's you can define your data structure as you want. It's your data structure, I would say. You have to find the right solution for your application or for your needs, I would say.
Okay.
But it will work in both ways. The difference is that you have to hand over the data root instead of the company then. So when you instantiate the storage manager, then you have to create a data root instance instead of a company. That's the difference. So instead of using the company here, in your case, you should say, let's use data root instead of company.
And I have to instantiate the company inside the data root or not? Like just declare it and create the getters and setters, getter etc.
Yeah, not necessarily, but I would recommend to instantiate the first one, yes. And it's also the same when you use collections. You should always instantiate this. In some cases, it could be, yeah. Let's create an array list in here, just to show you and let's say we have a company here. Companies.
Wouldn't you get otherwise a null pointer exception?
Yeah, that's right. Definitely. And that was a problem in the earlier versions of MicroStream, especially when you create, for example, you created a storage and you stored some data in it and so on, and then you add another collection to the data root, for example, which is totally okay. So you can add fields or collections whenever you want. But the problem was you get a null pointer exception all the time when you try to connect or try to access the companies. And for that reason, we recommend to do it like this, to add a null check within the get method. So we said, okay, you can do it like that. If companies null, then we say, okay, let's do this. That was one workaround, I would say, but I'm not sure if this is the case in the version 7. I'm not sure about that, but whenever you get a null pointer exception, when you added another collection on an existing data structure, then you have to work around this like this. But basically, I would recommend to instantiate elements all the time. But it's not necessarily needed. So, but you have to take care about nulls in that case.
Yes, okay. But I still don't understand how when you have some persisted data in the data directory, and you load the application, then how does it work? It will replace the companies with the data stored, and not with the object created in this let's say during construction of the object data root, because I don't know how it will restore from the repository to the data root. How the process how
this works, or
how it works to fulfill data, because I have the issue with the fulfill data from the data store, which is all previously stored. And I reload it, then it's not there. So I don't know why.
I think the problem could be that you stored the wrong object. That could be the case. So basically, you have to check if you start the embedded storage configuration or the embedded storage manager. You have to double check if you hand over the root object. And then you have to check if your store in some cases it's the problem like here, for example, some people do things like that. They create a brand and then they said, okay, and now store the brand itself. And the result in the end will be that the brand won't be saved because you store an object which is not available in the storage itself. You have to store the collection because that the collection has changed, and that could be also your problem. Maybe you have to double check this if you did the store in the right way and you instantiate the storage manager in the right way. Is that the case on your side? Does it look like this, or does it look different?
I just maybe I can share a screen for you to navigate.
Let me check if that is possible.
Can I do it here?
Zoom, I like it. Okay.
Share screen. Let's see.
Can you try to share it?
You cannot start screen share while other participants are sharing.
Okay. So I enabled you as a co-host. Now, are you able to share?
We will stop other screen. Okay. Yes. You should see now my screen.
Yes.
So here is my data root without instantiation. Here is the DB part. Create new data root. This one. And when I want to create a company, I created my company controller, and I get the comp URL. Then I set the car company as a new car company and store the root.
Okay. There, and then you have to store the root.
Just to figure out why this.
Can you show me the root again, please? The data root. Okay, we have car company here. Okay, that's Seems basically okay. The DB class again, please. Data root. Okay. Got it. And then what was the brand controller, right? So or the company
my
controller.
company.
Okay. The root set car company. Okay. Maybe the mistake is the store root method. You call it an internal. The store root is a, yeah, I know that method is available, but can you change that to db storage manager dot store and then use the object itself? So store and let's say db dot root.
Like this way.
Not the car company, because car company is part of the root object, and you in that case you changed the root. Okay, let's try this. Let's try this.
Okay. Okay, and I have it in the. I don't know how to hide the upper panel in the Zoom. So but okay. I don't know if you see my browser, but I guess no.
No, but that's okay. Just click on, yeah, the storage is initialized.
Okay, it's initialized.
Just check it out by yourself. It's totally
company
okay.
get, it's empty, so I will create some brand, second brand, oh no, so brand, second brand, brands are there. Now I will insert some cars, list cars. So there are 2 cars with 2 brands. Now if I stop the application,
okay,
and play it again, I will check the list of cars, so it's empty.
okay. New car company. But can I see the car controller, please? Can you car controller? Car company get cars. That seems to be okay. Get cars. The insert would be interesting. Yes. Okay, so you changed the you added cars to the collection within the car company, right? Then you have to store the car collection itself, not only the car company. So you have to say db root get car company dot get cars.
This one.
Because you changed the collection of the cars.
Okay, so I changed the collection, so I need to store the collection.
Yeah, definitely. Yeah.
And maybe it will be the same for the brand. So I change the brands, and here get car company. So maybe the same issue will be here.
Yeah, that's the same.
Get brands.
Yeah.
And delete is the same brand.
But that seems to be okay.
So it could be this one. So we'll try it again. So I will initialize the company, create some brand. Okay, and this is fulfilled.
But this is the most popular mistake by using MicroStream. That's
Dark. Okay, so car list is full of 2. So I will restart the application. No, car list is fulfilled. Okay, good one, thank you.
okay, great. I share my screen again.
So maybe that's an answer to my question. If I can store only the root document, I cannot. I have to always store the collection that I updated.
Yeah, that's right. Or it's all the time the same. Just store the object which has changed. And yeah, when you change a car, then you have to store the car. When you add something to a collection within the car, you change the collection itself. Yeah, that's how it works.
So every entity that are affected by the change need to be stored, or at least the most nearest parent. Like
I don't know if I get it right. So
store only the car or the collection.
When you insert a car, you have to store the collection because you added the car to the collection. When you make some changes within the car, you will have to store the car object.
Okay.
And if you have a seats collection within the car and you add an additional seat, then you have to store the seat collection, not the car. Because you changed the collection of seats within the car. And as I said yesterday, maybe I can show you this. We had a project. Give me just a second. The crop. Crop demo. I have just to check if you are on the right branch. So let's say Maven. Team switch to. Okay, just have a look to the controller class here. It was that example here. So change multiple elements at once, and we talked about that. As I said, okay, it's not the best way to store it again and again within that iteration here. It makes more sense to create a storer like this. And yesterday we used the lazy storer. So we created a lazy storer because this is the default behavior one. And it only stores the element which has changed, the upper element, I would say, or the element you hand over. But there is another possibility to use the eager storer in that case, and the eager storer stores all the child elements also. That means when you yes, in that case, for example, if you have a car object and within the car object you have a collection with seats, and you add a seat, for example, you could use the eager storer also to just store the car itself. And because of the eager storer, it will also store the collection of seats. That will also work. But then you have to use the eager storer. Because the eager storer stores the whole graph beginning on the car element.
Can I ask a question?
Yeah.
Related to this, would it in theory be then possible, let's say, if the object graph is not too large, let's say, and would it be possible then I just manipulate the objects in the object graph and only then periodically commit basically through an eager store the whole object graph to memory?
That is basically possible, but the question is if should I recommend that? Not sure.
No, that's okay. I won't call you out on that, but
basically that's possible. Yes, it is. Yeah, you will lose the data when you for example, when you store periodically, then you will lose data when the application tears down for any reason. But that's basically possible, yes.
Okay.
But we have to clarify the question. We had that question this morning. What happened when we use the eager storer? And we talked about that also about this yesterday. If the eager storer stores also the unchanged objects again, that is interesting. I have to clarify this. I'm not really sure about that.
But also the bidirectional basically relationships, then how is this? Is it then stored like if we have in the brands a list of cars, but also in the cars the brands?
That is what I said also yesterday. You should all the time create some data access objects, for example, and within that methods, for example, if you have an add brand method or an update car method, for example, you should take care about those bidirectionals also within that method. So that is part of the data access object.
Okay.
Maybe I can show you an example of that. Give me just a second. I have to switch my workspace for a short moment. Let's save this. Okay, so there is one a little bit bigger application here. It's a sales system. We use that internally, and this is also based on MicroStream. So, and maybe that is interesting for you to see. We have entities here and all the classes we need, and we created also some data access objects. And let's open an example one. Okay, and there we have all the standardized methods we need: find by mail, find by company, all that special stuff we need, or also the search customer, get customer, for example. And we should also have the update ones. For example, this one here. There is one update method, and you hand over the customer itself, and it stores. This is one possibility to do that, to store all the child object also, because in that case, you don't know what object exactly within the customer has changed. And this is one possibility to do that. But there is another one. We also were able to say, okay, db storage manager create eager storer. And use that eager storer. Let's call it es.store customer, and then we say es.commit. This is also possible. This is, I would say that's the same, but in that part I defined the collections below the customer to store, and the eager storer would do this for all child elements of the customer itself. Both is possible, I think. Is that clear?
Thank you very much. Yeah, that was very elaborate. Thank you.
But I think it makes sense to create those data access objects to have an additional abstraction layer between the entities and also the business logic or the controller classes. I think that makes sense to have those classes.
May I have a question related to eager storer?
Yeah.
Does it work recursively? or only on the one level of the object?
Yeah, it runs recursively. Yes.
Okay, thank you.
But we have to clarify if the eager store stores object again, if they are unchanged. But I have to clarify this.
Also, if you use the DAO, this means you do not go through the root of the store.
Yes, I do. These are only access methods. And I use the root in the same way within the DAO object. The DAO object is not an entity object. It's just a static method provider, I would say.
Okay.
Just to have another abstract layer between to not have those DB and not code like this within my controller classes, because when we change the framework methods on our side, you have to change all your controller stuff here, and otherwise you just have to change your DAO objects. That makes things easier, I would say. And it's on another abstraction layer between the MicroStream framework and the controller classes in that case. Okay, so give me just another more 5 minutes. I tried to reach Florian to clarify that again. Just a short moment. Okay. So I talked with Florian, and he said that in case of the eager store, it doesn't matter if the object is changed or unchanged or something. It will be stored all the time. So whenever you use the eager store, it will run recursively through the object till the end and store every single element in that below that main object and stores it. So that is how the eager store is working.
Okay, thank you.
Okay, and maybe there is an interesting difference, especially when you create an object. So let's say we add a book. So let's say like this one here. In that case, we said that the default strategy is the lazy strategy, right? So when we add a book to this collection, and in that case we created a book and we automatically added an author here. So, and that is an exception. When you use the lazy store and store a new object like we did it here, also the author will be stored. in that case, the lazy store stores also the sub entity or the child entities. But this is only on create, not on update. So for example, when we change the author within that object, within that book object, and we use the lazy store like we did here, so to say, let's say not create, but when we update a single book, for example here, let's say we change the author within the book object, and when we use the lazy store, the default strategy, then the author will not be stored. When we, oh, one moment. Yes, it will be stored because it's a part of the book object. Oh, yeah. But let's say we have a collection within the book maybe, and we create a new one. Then the content of that collection will be stored. I think that's the right explanation. So whenever you add an object, and you can use the lazy strategy to store also the child element, but it's only on the creation of an object, not on update. Okay, is that understandable in a way, how this works?
Yes.
Yes.
Okay. So let me just enable the chat again, and also this view on the second screen. Okay, we had another question in the chat. Why should we prefer Micronaut over Spring Boot? Okay, I think both are valid solution. It's totally up to you to use Micronaut or Spring Boot. I would say that's up to you. We have an integration for both systems. Yeah, no differences, I would say. I would prefer Micronaut because I don't know Spring Boot. I'm not an expert in Spring Boot. I knew what it is, but I've never used it. So I would prefer Micronaut because I know how it works basically. But it's totally okay to use Spring Boot. Not to prefer Micronaut, I would say. And the second one, if we decide for Spring Boot, what should change in our project? We will not use the Micronaut launcher. If you decide to use Spring Boot, you have to use the Spring Boot mechanisms to start the application itself. But the way to initialize a MicroStream, it's totally the same. And as far as I know, there are also Spring Boot examples in our GitHub repository. Let me just check this. There is one Spring Boot example, I think. Yes, as I said, there are two projects. Just check out this link. There are two basic projects within our GitHub repository, and maybe this helps to start with Spring Boot and together with MicroStream. There is also a Spring CRUD example in it, and yeah, basically the MicroStream mechanisms are the same on any system, but especially to know how to integrate, and so I think that will help. Is that okay for you? Okay, so let me just clean up my screen a little bit and get back to the car exercise again. So till the end, let's have a look to the car controller. So in that case, I used a get method again because it's just to find data, and I used a query value in that case to hand over the name of the model and the name of the brand. And in the end, on the Postman side, it looks like this. So let's have a look to the Postman, cars by brand, cars by model. You can see, you can see that here. It's it's just a query value at the end here. It's a get request, and it's one query parameter. You can check out this example and see how it works and how to add those parameters. Okay, any questions regarding the car exercise project?
In this project, there was a requirement to have a brand update method. What exactly was there expected?
Okay. Did I forgot that? Brand controller. Oh, you're right. So I should add this. I only have the insert one, right? So the update one is missing. Okay, you are right. I will add that. Thank you.
And what was expected there, to change the brand name or to replace the brand, or?
Yeah, I would say just to change the name of the brand. So
okay.
Because there is only one field in the brand, so
old name, new name, yes.
Yeah, that's right. Okay. Great. So let's move on.
Maybe sorry for that. Maybe I have one question related to delete method.
Okay.
For example, I created a delete method for brand, so I deleted the brand itself, and there is still a reference from the car to the brand.
Right.
So how to mitigate the delete the references between car and brand if I delete the brand?
If you want to delete the brand out of the car, you have to do it manually. But the brand will stay in the car as a reference, and that's totally okay, in my opinion. I would say that's how object-oriented programming works. So if you want to remove it, you have to remove it manually.
Yes. Okay. Okay.
And I would say in a lot of other cases, this is a big advantage, because when you think of a relational database, for example, it's in most cases it's nearly impossible to delete stuff out of the database, because all that constraints and that blocks you from deletion could be an advantage to be able to delete stuff. And it stays on the other side. Maybe it's an advantage.
Yes, we have to have it in mind that if you want to delete some object, then we need to delete all the references to the object.
Yeah, then you have to search for those cars with that special brand, and then you have to remove it manually. Yeah, but I think that's okay to create a method like this, because it's I would say it's a quite heavyweight impact to the data itself, and it makes sense to take care about yourself instead of using some database logic like how was it called on the relational database? It's a transient. No, it's was it called transient? Not transient. Yeah, it doesn't matter, but there is a special name for that on the relational database to delete all the related objects to.
You mean the cascade?
Sorry?
The cascading.
Cascading. Thank you. Yeah, that is the right word for it. Thank you. Yeah, and I think that cascading stuff is quite dangerous to use it, and But I think now in the newest Hibernate version, it works really great, basically. But in the past there were some problems with that cascading stuff. But yeah, anyway. Okay, so I would say let's jump to the streams part for today. Just let me clean up my screen a little bit. And some of you might say, okay, streams, I know everything about streams. That's quite boring. But all the time when I talk to different persons on some conventions or something like that, it's interesting that people don't use those streams that much, and so that's the reason why we have that within the training. It could be very helpful, especially with MicroStream, of course. Okay, just so we have that fundamental. We don't need that anymore. So I created a short presentation, but I have to find it. So streams. Okay, here we are. Now I just have to do this. I created also a project for this, and I will forward also that project to you. Streams. Java 8 streams. Yeah, here it is. Okay, here's the URL for you. That enables you to clone the project. I already did that here, Java 8 streams. And let's start on the branch with the name. Yeah, directly on the master branch. That's okay. So when you open the project, it contains compiler errors. That's quite normal, because all the endpoints here doesn't have any return values for the moment. That's okay. So we will do the following. So that means we create or we will go through the presentation, and I will change or switch all the time between the presentation and the code here. And during the presentation, we add the code directly to the project itself. And I need some. Okay. Controllers, streams control. Okay, so where is the presentation? It is here. Let's start it. Come on. What's wrong? Here we are. Okay, MicroStream, Java 8 streams. Without the Java 8 streams, I'm pretty sure MicroStream would not work. Or we had to create an additional search API to search through an object graph. Of course, there are some frameworks on the market, like what was the most popular one? It's GraphQL, which is also compatible to MicroStream. But yeah, in my opinion, it's quite complicated to use. Some of you used GraphQL or using it at the moment?
Yes.
Okay, and what do you think? Is it to get into it? It's quite hard to get into it, right?
You mean as opposed to the REST paradigm, or
yeah, of course, yeah.
Yeah, I used it for 2 years in a startup company, and I have to say, well, the beginning, it's kind of something new to have contracts if you come from the REST world, but then in the end, it is actually really nice to work with. Yeah.
Okay, sounds good. Okay, what is a stream? Basically, let's go through the definition of a stream. So basically, it's an aggregate operation, computes a single value from a collection of values. This is the basic definition, and the result could be, it could be a primitive value. It could be possible to get a primitive value out of a stream, to get a customer out of a stream, a list of customers, void, or an optional customer. These are the possible results we can get out of a stream. And a stream could also be a sequence of data elements supporting sequential or parallel aggregate operations. So that is also, and this sounds quite, like I said, this sounds quite complicated. In easy words, I would say it's a query language for Java collections, and it's a modern way to process collections. I think that fits best as an explanation what streams are, and what streams mostly used. So I think that's the best explanation. So we are able to query a Java collection and process collections. And let's jump in the basic of a stream for processing data with no return values. And maybe some of you knew that, but we have things like, things like an in-stream. It's an alternative to for, or we have an array stream, an alternative to while loop and for loop, and we have a collection stream. And I think these possibilities are really great to use. An in-stream of, or an in-stream with a range between 5 and 10 for each. That is also working really great. And the while alternative, so let's say we have an array with some numbers in it, then we are able to say stream.off, and then we can add those numbers and we can create a for each out of that. Or an arrays.stream nums for each. And I think the last one is the most obvious one, db.root.getBooks, and then we say for each. We used that many times before. And let's stay here and let's use this within the project. I created 3 different methods here for you. Let's add an in-stream. So let's say in-stream. So, and if you want, you can code along with me. There is also one branch. Of course, all these stuff is already implemented, but yeah, let's take those time to do that, to type that. I think that's okay. So let's say off, then we have int values, and then we can say 1, 2, 3, 4, 5, 6, 8, for example. And after that, we say for each. Let's use an I for, and could look like this, or could also look like this. Just a second. Approach could be to type it directly, not as a lambda, or more like a lambda. Let's say system print line I. Or could look like this. And there is another one, the in-stream with the range. In-stream with the range, with the start inclusive and end exclusive. Let's say start with 1 and end exclusive, then we have to say 11 dot for each, and it's the same like this. That's why I'm copying this one or this. So okay, I think that are great alternatives for or to for loops. I use that mostly now instead of for loops, especially the range one here. That is yeah, it's really great working. The next one is the create the array streams. We have it here. So, and for that I need an array first, and I also created one. I can just copy this also to you. So we have integer numbers within an array, and the streams give us the possibility to stream through an array. And for that, we use the Java util stream.off these numbers, and then we can say for each. Basically nothing special. Yeah, this is Java basic stuff, I would say. And just to complete the third one, the object stream or the object stream, we used it many times before. db.root get books for each, and add a b for book, and then say b.get name. Nothing special so far. You have that? Then I would switch to the next part of the streams that are the easiest ones. Let's talk about the collectors. Every stream needs a collector in the end, and mostly it's the last part of the stream. So that means whenever we stream through books, for example, let's say db.root get books, then we need those small word stream. We need that all the time. And then we can say to array, for example, and create an array out of the books, for example, or to create a list out of books. Let's say we have, no matter what collections we have here on this side, we can stream through the books and say dot collect, and then we use collectors dot to list or collectors to set. And I think this this one here could also be quite helpful. There is that string join collector, and there are many more, of course, many more collectors. This could be quite helpful to have a list of pets. I have that here because to create one, but in the end, I want to have a string separated with a comma, and then I can use the joining one, the string join. That could be quite helpful in some projects. There are another two collectors, especially for single values, not for collections, but for single values. It is the find any collector and the find first. And basically, the find any and find first, they return, normally they would return optional values, and that's the reason why we use that get in the end. But you should not do that in that way. You should check if the optional is present, and then say get. Maybe there are possibilities to check that within the same line, but I'm not sure about at the moment. What are the differences between any and find first? Someone of you know that? It seems that could be the same result, right? So find any and find first. What are the differences? Some of you know that?
I understood as so that if you are not sure with order
Yeah.
of coming objects in the stream, then you use find any takes any of the objects, and find first takes the first one which is coming if the stream is ordered.
Yeah, that's right.
As I
but
know.
that makes not really differences when you use the normal stream, but when you use the parallel stream, that will be interesting, because find first returns in fact the first occurrence in the order of the list, and find any then, especially when you use the parallel stream, it will returns any finding in any thread, I would say. It doesn't matter in which order it is. So, and that is the difference between find any and find first. But to be honest, in combination to the normal stream, I think the result is the same. But with parallel stream, it could be different. Okay, find any, find first. Let's jump back to the Java code. The array collector, let's do this. Yeah, this, let's say, okay, db.root.getBooks.stream. So, and as I said, this is also possible to use the parallel stream, but let's use the stream in this case, and let's say collect. And after that, collectors. Oh no, it's different it's different on the array side. Let's say to array. And then I have to use the function of this, let's say book array, and let's say new in that case. So we create an array, and of course we need to return this book array. Maybe in some cases that might be helpful. To be honest, I never used that, but it's possible. Okay, another one. The next one is also really basic. Let's say db.root.getBooks.stream.collect collectors.toList. And this part, we will need this part quite often when we use the Streams API. You will have this in a lot of many streams. The set collector is the same, but it's not toList, it's toSet. But basically, but also, yeah, just change the collector itself. And then we have the string join collector, and for that, just create a small list of animals. And then we say, okay, let's return only one string with separated by a comma, and I have to import the arrays first. Yeah, that's it. Collectors.joining. And as you can see here, there are many more. We talk about that later on when we go to the aggregate functions, grouping, joining, and some more, max and min, reducing. And yeah, it's kind of like an SQL syntax. Yeah, I think the streams are powerful as the SQL for sure. Okay, then we have to find any. We already talked about this. Let's say it's always the same part, db.get root get books dot. Let's use the parallel stream dot yeah, we can use that directly. We can say find any. So that means give me one book out of many, and doesn't matter what kind of book or what book especially. So let's use a return book find any dot get. Yeah, we will get an exception if the collection is empty. In that case, let me just check if there is a possibility to if present. Yeah, that could be a solution for that. If present, then you can add that consumer, but empty of nullable. Yeah, it doesn't matter here, but find any, find first is also nearly the same, find first. But I would recommend to use the stream here instead of parallel stream, especially when we just want to have the first object of a collection. It's kind of like the same to say, give me the object with the index 0, for example. Or it's the same like, yeah, as I said, get books dot get index. Yeah, this would be the same. Okay, these are the very basic streams method, and it starts always the same. So we have a collection of objects. Then we need the special word stream or parallel stream. And at the end, we need those collectors most of the time. So we have collectors. So this is the beginning and the collectors. Now let's talk about the stuff in between. So let's jump back. And there are some filters or possibility we can use filters in that in between, though. That means, as I said, we have the get books and stream, and then we say, okay, let's filter within that streams. And in the end, we have to say, okay, collect and collectors dot to list. So that means find B get name starts with an A. We already used that in yesterday. Could also be the same with equals. Just to be rude, what is the point here? Stream find first. Get. Oh, there's something missing here. Okay, that is wrong, definitely. But this is also interesting. Just yeah, the predicates here, especially when you have multiple filter constraints or predicates, then you can do it in this way. This could be quite helpful to keep the code more readable. So the first predicate is the name predicate. So that means B get name equals this Bangkok dangerous. There is another one, get ISBN equals 1, 2, 3, 4, 5. And the third one is a combination out of the name predicate and the ISBN predicate with an AND. So we say name predicate dot AND, and then we add the ISBN predicate. And now we are able to use only this one statement to say, okay, DB root get books dot stream, then we say filter, and then we are able to add the name and ISBN predicate. And in the end, we will say, okay, collectors to list. Let's switch to the code. And therefore, we have to switch to another class, to the book controller class. By title, This should be right. Give me one moment. Okay. Controller. Okay, let's start with get books with an A. We already used that. So let's say db.root.getBooks.stream or parallel stream. In that case, it would be possible to use the parallel one. Now we need the filter. Filter. Let's add a B for the book. B.name or get name dot starts with an A. And after that, we need the collector. Let's say collect and collectors dot to list. So let's split up this a little bit. So we have the parallel stream, and then we have the collect statement in the end. And let's add a return. Okay. Parallel stream, filter, collect. These are the three main parts of the stream. I think that is the next one is mostly the same. That's why I copied that statement, and we just have to change this part here. Let's say b.getName equals or equals ignore case. Let's say, yeah, something, any name. And now the predicates are interesting. So let's say we have one predicate. It should be this one. It is type to book. Let's say name predicate. Equals b dot get name dot equals yeah, same one. So this is how a predicate should look like, and let's copy another one. This is the ISBN predicate. Just change that, get ISBN equals 1, 2, 3, 4, 5. And now to combine these two predicates together, it's the same here. Let's say predicate book, name and ISBN predicate equals, let's say the name predicate dot and. It's also possible to say or and the ISBN predicate. And then we are able to use this predicates. And for that reason, I copy this, and instead of using the filter like this, I add the name and ISBN predicate. That's the same. And as I said, in my opinion, it's quite helpful to use predicates like this to keep code more readable, especially when you have huge amount of filter criteria and something like that. This will help definitely. Ah, yeah, okay. So Uri wrote an hint for checking the empty. You can use the optional or else get. That might help, yes.
And there is also some or else methods.
Yeah, definitely, yeah. But there are tons of good documentation to the streams, and I think you cannot have all the streams or to keep all the streams in your mind. So I have to read also the documentation all the time because I don't use it always. So okay, so So let's jump back to the presentation. These are the filters. Any questions so far to the filters? Yeah, nothing special. I think that's, but it's important to know, especially when you use MicroStream then. Let's talk about maps. Maps. A map stands for map the result to a different result type. In some cases, this is quite important to know how this works. And I would say for me, it was to understand how maps are working. That confuses me a lot at the beginning. But now, okay, a map is map the result to a different result type, and a flat map stands for map the result to a different result type collection. So that means whenever, so in this case, for example, we want to have a list of authors, and author is a child object of books, but it's a single object. So then we can say db get books, basically. So we stream through the books, and then we say map and give me not the books as a result, instead of give me the author as a result, at the result list, I would say. So whenever you have whenever the target object is a single object value, you have to use map. And the other point is when the target object are addresses. So for example, the author has a collection, a child collection in it with some addresses, then you have to say flat map, and then say a.get addresses dot stream. You have to stream through the addresses, and then say collector dot to list. So whenever the target object is a collection, then you have to use flat map. If it's a single object, you have to use the map instead of flat map. So let's go back to the code. Let's find the right get all authors, get all addresses. So these are the two methods. So let's say return a db.root.get books dot stream so now I want to have the author instead of books. So now I say map b for books b dot get author, and then I have to add the collectors dot to list, and that's all. So whenever it's a single object within the book object, in that case we need to use map. Let's split up this a little bit. And instead of using the collect here, you could also do something like this. So you could also do stuff like say, okay, dot for each, for example, to process the authors. That's also possible. After that statement, you will get a list of authors. So when we use a for each here, for example, then we have authors in it. So let's say a.get, and here you can see the addresses, but we need that addresses later on. But after that map statement, you are on the author layer.
but wouldn't the for each would not work, or because it's a terminal operation?
Yeah, in that case, of course, because it's a return, and so yeah, you're right. But it's just as an example to say, okay, it's also possible to add a for each, but not in that case. Yeah.
Okay. Yeah.
Let's do this, the flat map part on the address list. Let's say return db.root.getBooks stream flat map, because I want to create a collection out of the inner collection. But there is okay. I have to use a different. Okay. I use this one in my example. Okay, not iterate through the books. So I use the get all authors method in that case, and I stream through all authors, and then I say, okay, flat map. A stands for author, a dot get addresses dot stream. That's important to stream through the addresses, and then I can say collect collectors to list, for example. So this is the first part. Then we have the flat map part with the stream in it, and that's the collectors part. Map and flat map. That's also two important functions, because so let's say when we want to have only specific addresses out of that, then we have to add another filter here. So this will also be possible. So let's say we only want to have addresses with get addresses. Let me check that an address have an ID, street, zip. Yeah, let's say if you want to have specific addresses out of London, for example, then it could be possible to add another filter. Now from here on, the stream starts from the beginning, I would say. So let's say, okay, a get addresses dot stream, and now I can say, okay, dot filter, and I have to use a different identifier. I use AD for address, and let's say AD dot equals no, sorry, a dot city, get city dot equals normal, something like that. So now, and in this case, streams becomes sometimes more and more complicated, and that is the reason why I recommended those predicates, because in some cases the streams could be quite are confusing, I would say, and that predicates would help. So that means when we use flat map, we are also able to filter in another child collection. But in this case, it's not necessary. But let it keep it in the code. That's okay. Okay, we should not have any compiler errors anymore in the book controller class because we filled everything. Let's jump back to the presentation. Are there some more features of streams? And there are some aggregations. Only a few sum and group by. This is could also be really helpful. And this is not, as I said, in a lot of cases, I have to read the documentation for those sum and group by stuff. it's not possible to keep that in my mind. So let's do this in the books price summary. So let's summarize the prices here. So the basic stuff, or the basic part, is really straightforward. Let's say db as always .root .getBooks .stream, and then we can directly use the collect and collectors dot reducing, so stands for summarize. And now because it's a big decimal, so we have to define the big decimal 0. 0, comma, and then we need the 2 lambdas. Let's say book get price. This is the value which should be summarized, and now we have to define the method to summarize or to add this. In case of big decimal, it's the add method. So reducing means start with 0. This is the value which should be summarized, and this is the method which is provided by the big decimal class to add or to summarize values. And we need a return. And as I said, there are a lot of different functions: average, double, average, int, long, counting stuff, grouping, joining. Yeah, a lot of different, a lot of functionality. I think it's important to know what is possible, basically, and search for some documentations if you need it. Okay, so did I forgot something? Okay. This should look like this: books price summary, books group price sum. I think that's the right name for the method here. So let's do some group by stuff. And for that, let's say db get root getBooks dot stream, and then say collect as always dot and collect collectors. Grouping by function. So we want to group by the get author method, book dot get author. This is the key part. So let's group it by author, because we will get a hash map in the end. And then we have to say collectors. So we need an aggregate function now to group the other stuff. And for that, we need the same collector we used here, the big decimal collector. So we can copy this. So let's say collectors reducing big decimal, it's the same. So, okay. Let's check if I'm right. So let's do it like this. say stream, we have that. Then we say collect, collectors, grouping by, we have the book, get author. Okay, this is, yeah. So, and out of that, we get an hash map or a map in that case. But yeah, it's the same. We have the author as a key, and we have the summarized values as a big decimal as value. And we need, of course, we need a return. Let's say return collect. Or let's call it result or something like that. Yeah. Okay, let me check. We have the last part is the sorting part. We are also able to sort stuff in reverse order. We have, this is the normal sorting part. Okay, let's say sorted, comparator, comparing. I think that's really straightforward because we need those comparators all the time, not only in the streams, but they are working quite similar. Comparing or the comparing reversed. I think that's nothing special. And with that, I will lead you to a small, let's say, exercise. There are, let me check. This okay. So when you move to the there is another branch within that streams project, which is called switch to other. Stream implementation done. Let's check out this Discord changes. So there is, come on. No. There are, okay. So just create another exercise controller. Try to figure out by yourself how to write down these streams. 3 exercises. Get books from female authors. Try to find the right solution, or get authors from Poland, or get books, or get all books before 2012. Try to find solutions for that 3 examples, and let's say, or let's see if you can find the solutions for that. Let's say, let's do it for 10 minutes around, and after that we will have a short break. If you have a solution for the first one, just copy it to the chat, and I have to change this so that these there is not the result within the branch. To see the mockup. Yeah, to see the authors, there is one, it's female or male as part of the this are the identifier, I would say, female or male. So any one of you want to share the solution for the first method? I would say it's the easiest one. No one? Okay, so let's say db root getBooks.stream. That's the basic. We will need a filter. And in the end, we have to say .collect collectors to list. This is the interesting part.
Yeah, basically just a lambda now where we take basically the book as a parameter, and then we just say get the gender, and it's basically yeah, equals the gender that we are filtering for.
Okay, that's right. So get the author, get the gender, and then we can say equals ignore case, and then we have the female. That's it. That's right. Nothing special. It's the easiest one. Let's go to the next one. Authors from Poland. This could be a little bit more challenging. So it basically starts in the same way. So we have a books and stream. And we have a collect in the end. So we need
this can use a flat.
Okay, go on, please.
Stream through the authors and just extract the authors again, using a filter on their country of residency.
Okay, so let's say, so we have to extract the author. That means we have to use map, right? So map, let's say book for b.getAuthor. So we extracted the authors, right? So, and now we need to filter on the authors. So let's say filter. And let's say this filter all dot get addresses.
Yeah, sorry, we only need a map. Yeah, author is just a single object. It's not.
Yeah, that's right. Yeah,
or it's not a list. Yeah, it's not a collection.
So then we have to say filter, but the addresses is a collection, and there is of course we could do a flat map now to find the addresses, but there is a better way to do this, and for that reason I created a predicate. So in that case, I use stuff like this. So I create a predicate to just have the filter to say, okay, A is the address, and then say get country equals ignore case Poland. That is the basic predicate. And I use that predicate to say get addresses dot stream. And then I can say we had that before, that any match statement, and I can say any match the Poland predicate, and that helps in that case a lot to find, because that's a list, and otherwise you have to find another solution to stream through the addresses and filter those addresses are from Poland. Then it's easier to use that any match method. And of course, we have to return the result. Okay, and the last one, all books released before 2012. So that is also not that complicated. But there are several different ways to do that. In my case, I created a local date of January 2012, and I say b.stream.filter get release is before the start date. But there are many different possibilities to do that in another way. This is only one solution for that. Okay, any questions to the streams API? Some of you might say, okay, streams are nothing special, or nothing special for me. I knew all that stuff. But for many other developers who started or who are used to work with Hibernate and they use SQL all the time, it's quite challenging to understand how the streams are working. So could be helpful to see all that examples how to use streams. Okay, let's get into it. Let's talk a little bit about lazy loading, and let's do also some research within the next few minutes and before lunch also, and maybe we have to do some more lazy stuff after lunch, but let's see. Okay, so lazy loading, in my opinion, one of the most important topics using MicroStream, because some people ask me all the time, okay, what is the use case for MicroStream? And I would say basically there are tons of different use cases together with MicroStream. We use MicroStream a lot in smaller projects as a normal database instead of using any relational databases anymore. So MicroStream fits good for any low and medium-sized projects. That is great. Another use case would be to use MicroStream as a cache, just cache data. And I would say the same like Apache Lucene, for example, or Elasticsearch. MicroStream could be used as a cache. Then MicroStream could also do a great job as part of a big storage. Let's say we have a really, really big data, terabytes of data, for example. But for most of the data, we don't need such a huge performance to load the data and write data into it. And mostly you need this performance only for a small amount of data. And for this small amount of data, you can use MicroStream. So as you can see here, there are a lot of different use cases for MicroStream. And but there are some cases where to say, okay, I want to use MicroStream as a normal data storage, but it's not possible to hold all the data in memory. And then you have to take you have to use lazy loading. But we can show you how to use lazy loading basically, but how to use lazy loading in a proper architecture or object architecture, that is, I think, the important part of for today. And for that, I prepared a small project, and we do some researching. So, but the basic stuff is, why do we need to store and load data in a lazy way? What data should be stored and loaded lazily? How to use lazy references, and some best practice examples. And this is also important, how to release lazy data. So if it's loaded, how to clean up those lazy references again. You will find also a lot of lazy loading stuff within our documentation, and there are also a lot of different examples on GitHub available. But yeah, let's have a look why lazy references are important. So basically, MicroStream, as I said, is an in-memory database framework. So that means that is one reason why it is so fast and performant. But there is another point, the missing mapping, of course. It's also the reason why it's so fast. But basically, it's an in-memory database, and you will get the best performance when the data is in memory. And for that reason, you have to choose a server which has that amount of RAM which is needed to keep your data within the RAM, basically. But in some cases, that's not possible, and especially when binary data comes into play. For example, this is one example: binary data, documents, something like that should be all the time lazily loaded. That's one point in this case. And sometimes it's just unnecessary to hold all the data inside the RAM. For example, historical data, archived data, or something like that, logs and something like that. It's not necessary to have those data all the time in the RAM, because when we want to access the data, it's okay to wait for it, or we don't need those performance on that data type. But we need a way to decide which data should not be loaded to the RAM on MicroStream database startup. By default, when you start MicroStream, all the data will be loaded into the RAM. So that means when we have 1 million objects on the disk, on MicroStream startup, you will have 1 million objects in the RAM. This is how it works. Without lazy loading, you will have this result at the end. All the data you have stored in MicroStream on startup, this data will be loaded into the RAM. The only way to prevent that is to use lazy references on certain nodes. For example, like this, when we have lazy here and lazy here, then the result would look like this. So we only have those, let's say, proxy objects here, just to know, okay, there is only the lazy references available here, but not the data itself. And that could be a way to decrease the amount of objects on the server, and that could help a lot. And you should use lazy a lot. I would recommend that. Whenever you can, think about what data is important to have it in the RAM, which is not important, and you should use lazy a lot, basically. But when to use lazy loading? I would say basically always on binary data. Whenever you have documents or images, movies, something like that, always use lazy loading. Blobs, documents, images, and so on. You should also use lazy loading always on huge collections. So let's imagine we have collections with 1 million or more objects. You should use lazy loading, but let's talk about that later on. And especially with less frequent data, that's an important point. Logs, archive data, and so on. You should use lazy loading sometimes when entities have a huge amount of sub-entities or child entities. Could be helpful to add a lazy reference to those child entities. And basically, whenever you want, if performance isn't that important in this part of the data model, or the amount of RAM is limited. So that is, I would say, these are the basic rules of using lazy loading. How does lazy loading work? Basically, for binary data, this is one example. It could look like this. So it's a lazy wrapper class, which is typed on the type which is normally available. So in that case, we have the byte array for an image, for example. But it could also look like this, that we have a map with a string as an identifier. It could also a more complex object to have some more informations about the content of the byte array. And this gives you the possibility to search for some special byte array stuff, and then you can load only this small part instead of using all at once to filter, for example. So this is the basic way lazy loading works. So we have the lazy word, so the lazy wrapper class, and then you can add your image. Yeah, as I said, images or documents, something like that. Huge collections. For example, when we have a huge list of books, then we are able to wrap the whole list of books within one lazy reference. And the way to initialize that looks like this: lazy.reference, and then we have the new array list of book. That is also quite important to know how to initialize a lazy reference. I would say best practice for most low and medium sized collections, especially when it's not. So let's say we have to iterate through the books, then of course we have to load the whole collection. That means if you have 1,000 concurrent users on your server and you want to access books and they iterate through the books all the time, then I would say it makes no sense to load it lazily, because it's loaded all the time anyway, because most of the people are iterating through those books. So you have to think about that. That's important. It has to be low frequented, I would say. Then it makes sense. But if you have a lot of users who are working all the time on a list of books, that makes no sense to lazy load those books in that way. Yeah. That's
can I ask? Sorry for interrupting you.
No problem.
So in this case, would you rather recommend, as you I think had in the previous slide, that you have, let's say, a map or a hash map,
definitely,
and you only, let's say, even if you want to check if a certain entity exists in your graph, then you can, the ID would be, for example, the key for the map, and so you can check this without having to actually load the actual object behind it.
Yeah, I will come to that later. So we do some examples, and yeah, but you are totally right. A hash map could help a lot in that case. As I said, the usage of a hash map could help, especially to do some search stuff on the keys. And this is like an index. For example, this could be an author. Let's store in that list only the books for a specific author, for example. Then the authors could be an index for those books, or the first 3 digits of the ISBN, for example, could be an index for lazy books, for example. This is totally up to you, but it's definitely makes more sense to have a structure like this, especially when you have huge collections and you have to find a way not to load all the books at once, instead of using just small parts of those huge amount of books. Definitely, but we will do also know an example of that. Yeah, let's use an index. That would help. And to release the data, there are 2 different strategies to release the data. It could be it's a possibility to release the data manually. There is a call which is called lazyimage.clear. And of course, you have to do a garbage collection in the end if you want to have the data, or if you want to have the RAM now. So then you have to do also garbage collection. But basically, lazy.image.clear is does the job to clear to unload the lazy parts. And there is another one. There is another possibility to use the automatic one. And this is also the default implementation. There is a lazy reference manager, and it runs every 30 minutes. And that's wrong. It checks the lazy reference every 30 minutes, of course, and checks if there are some parts that are older than 30 minutes, and it will be deleted or will be removed out of the memory. And there could also be an adjustment to say, okay, let's do that lazy checker whenever we have a memory quota of 75%. That means there is an automatic way, and there is also a manual way to clear those lazy references, or to unload the lazy references. Okay, let's do a little bit of research. I created a project with persons in it, and so I created this create person method, and I create 200,000 persons on calling this, and the person itself, it's a person like this, a UUID, first name, last name, male, gender, IP, and we have value 1 and value 2. And just to give you an idea how the data looks like, the value 1 and value 2 are huge amount of strings, or like a book content, for example. So quite a lot of data. Let's start this application, and let's see what happened when we create the data. So let's run it, and you can do it together with me. If you just check out the lazy demo, you will need the visual VM to see the memory consumption of that project, or you just have a look together with me. That's also okay. So quite a lot of windows. So let's go to the browser and call this application. Get persons. Okay, let's try to get those empty list of persons. So it's called persons. So no, just a second to see 8080 localhost. It's up and running. Persons. Create. So I get this result, but that is not the right one. What is wrong in this case? The port is okay. Persons. Oh. Let's try to start it again. Or just to ensure we have this the right project. No. Switch to other. Start. So change person train. Okay, what do we have here? Just a second. I have to find out what's the issue here. Change to files and change mockup strategy. Okay, it's already in place. This is also okay. Let's try another branch. Maybe so remote. Change to okay. Check controller, get persons. Let's use the init one. Person/init. Okay, this seems to work. Okay. Okay, so okay, we have around 16 megabytes at the moment. Just to show you what I did, I called the persons the init endpoint, and the init endpoint just ensures that the storage manager is initialized, and of course, when we do a refresh here, you can see the data folder here. We have 4 channels, but there is no data in it. It's empty. So let's call the next. Let's call the create person call here. And the difference between this branch and the one before is the persons are lazy loaded at the moment. So that means, oh, let's go to the data root. As you can see here, we have the lazy wrapper here, and it wraps the whole list of persons. And yeah, that's okay. So let's have a look to the DB class. Come on, what's wrong here? Oh, so there is no lazy reference manager implemented, so it's not running. So MicroStream does not clears the lazy instances automatically. So that's okay. There is also no lazy clear in it here, and let's call the create person endpoint and see what happened on the RAM. So let's perform garbage collection. Okay, so where's my browser? Yeah. Let's say create. Okay, what happened here? So it creates 200,000 persons now, okay? And we have, at the moment, we have 1.3 gigabytes of memory used at the moment within MicroStream. And all the data is in the RAM, of course it is, because it's stored when we do garbage collection. Okay, it decreases a little bit, but the problem is that we uploaded the data, or we created the data, but we didn't clear the lazy references. But the important thing is when we stop the application and also clean the VM and start the application again, the data should not be part of the RAM. So that's the first important thing. Let's start MicroStream and Micronaut, of course. So let's get into the monitoring, and let's call the init persons init. As you can see, the memory stays small because all the data is loaded lazily. Let's iterate through the data. So let's say, let's get the persons. Then you will see when we iterate through the persons, the data increases again. And here you can see all the data within the browser. So let's highlight anyway. It should work. Okay, that is not working as expected, but too many data, I guess. Okay, but it's the same memory consumption at all. So let's perform garbage collection and it stays the same. We don't have any mechanisms to clear or to clean up the lazy references. Let's enable those cleanups. So let's say, okay, clean up the data every minute, or don't keep memory, or don't keep objects longer than 1 minute. Let's see if this is working. So let's delete this. Let's start the application again. It's Java application. We have that monitor. So, okay, let's go to the browser. Let's load the persons. Memory increases as expected. Here is the data. And after 1 minute, the housekeeping process and the internal garbage collection of MicroStream should clear all that objects from the heap. Now let's wait a little bit. So we have 11:46. Five seconds more. Okay, and as you can see here, the garbage collector of MicroStream takes care about to clear the lazy references out of the memory. So as I said, this is working great. So you can use this, and you have also to check or to, you have to check this, what fits best for you, how long to keep the data within the RAM. And do your adjustments yeah, up to your object model. So there is one question from Primo. How does this scale? What if we have 2 million persons? Check it out. Let's try this. We can do this. Let's run the create statement. As I would say, definitely it depends on your data model. So do you have a huge amount of strings or huge strings, or do you have a lot of binary data? This is totally up to you, and it depends a little bit on how many lazy parts you use. Yeah, but basically, give me just a second. Let's load some more, 1 to 200. And one, let me just check, load mockup data. It loads how many persons are, so there are 1,000 persons in it, 200. Then let's say 1,000 would be 1,000,000, right? So let's say 2,000. Let's try it out. I delete the data. Let's run the application. So we need virtual machine monitoring. This one, monitor. And we have the browser. So, okay. Persons init. Let's init the storage. And now let's create the persons. Okay, now we should have 2 million persons now, and we are at around, okay, it's still working. So what happened here? Okay.
You probably hit the limit of the application heap dump or heap size.
Okay, could be the case. Yeah, that's the maximum amount of. It restarts the application, right? So it seems so. 4,000. But we enabled the clearance, and it's okay. Yeah, okay. This is also a good example. So that means it clears the because the data is lazy loaded. So again, so let's have a look here. The persons are lazy loaded, and when you add the data, there is a memory quota within MicroStream. And it clears the data when, but the data is now available. And a problem will be when we now want to get all the 2 million rows. Let's do this. Let's try it out. So now let's load all the 2 million persons. So let's have a look what happened then. Oh. Let me. Okay. Not sure what's happened now. So let's start the application again. And what is more important, let's check the data. So this is the data folder. Let's check how big it is. So I have some properties. 318 megabytes. That is not the full amount of data, no. Definitely not. Okay, we have to check what is the reason for that. Maybe it reaches, in fact, let's do this. Just a second, I've checked the documentation of lazy loading. Just to add the memory quota. Duration 2 millis. Yes, and then, and let's say 75 point. So, okay. Just to ensure that the memory will be, or the references will be cleared after we reach 75% of the memory. Okay, so delete the data folder, start the application again. Check the monitor and no. So there's my browser. Here is it. Let's say localhost. Persons create. Okay. Okay, the behavior is the same. Okay, so I have to check this together with Florian. Maybe it's the right behavior, but I'm not sure at the moment if this should work like this.
What if you call the get persons endpoint, right? It would be interesting to understand if the data is all there or not.
If the persons are in it, right? So
yeah, if they're all there, okay, and the whole memory behaves.
Now it says persons are created successfully, so that means we don't have any mistake and or any error or exception. Let's call the persons, and they are empty. So, and this is something went wrong, definitely. So I have to find out the reason for that. Let's decrease that a little bit. Let me check 200 times 200,000. Let's create.
Do you maybe have some constraint on the memory that the virtual machine can take? Maybe it's taking too much RAM and kind of explodes.
I don't know what the default configuration is for the Micronaut application. So I have no idea how to increase the
Yeah, we should go in the running the arguments that we pass to the Java virtual machine when starting the Micronaut application, but maybe it's too complicated to do it now.
Part of the maybe that's part of the Micronaut configuration. Let me check this during the lunch. Maybe I can find a good, but I want to move forward to, I think, I'm not sure if it makes sense to add such amount of persons to one collection. I think a better solution would be to split up this person. And for that reason, I have another branch. I think that makes more sense in the end. So let's move on to the next branch. Change to multi-maps. Let's go directly to the last branch.
Could you please also copy us the GitHub, the URL?
Ah, yeah, for sure.
Yes.
So here's the link. Okay, so this is step 3, the multi-map solution. And let's have a look to the data structure now. So it's a little bit different now. So of course, I have the person. It is unchanged, the object itself. And I created a second one, which is called persons. And this class contains multiple maps and with different indexes. So that means we have a string, and this is persons by last name. So that means I have the last name here, and then I have a list of persons here. And I would say it's only the first 2 digits of the last name is in here. And it's the same on list by mail. Only the first 2 digits of the mail is part of the key. And it's the same here, first 2 digits of the person ID. And the big advantage is that you don't doubles or you don't have the data 3rd times within your RAM, because there are only references to one person object. And that makes it possible to have a structure like this. And it makes more sense now. So I have to say, the biggest problem is that when we have a controller like this, for example, get persons, it does not make sense to send the whole data instead of sending only the ID of the person. This is, I think, that is the basic approach of REST endpoint. You should keep the endpoints as because you have to load the data basically, and then you have to transfer the data to JSON, and that doubles the amount of data on the server. So that means don't send a huge list of persons directly. So just send only the ID of the person, or only a small amount of data. You know what I mean? Just send smaller data. It's not, I would not recommend to send the whole list of persons. And that makes things even more complicated. It's not only MicroStream which needs memory, it's also the mapper, for example, the JSON mapper of the REST endpoints. So, but let's check what is the memory consumption of this branch. It should be definitely different, but let me just check how the storer works. Okay. Yeah, I just have to check if there is another branch. Multi-maps, basic image implemented. Yeah, it should be. Okay, that is the. Okay, let's start this. And just check the amount of. Let's increase this a little bit. Let's increase that to 600. And now let's start. So that's new one, the monitor. Okay, so create those persons. Maybe I should use the post screen instead of the browser because so it makes more sense to use this. Fundamental, no. And who are those access lazy? Person create. Okay, let's set this. Oh, is the application. Okay. It's already running, so get an internal server error. Maybe the reason is the implementation. It's only made for that 200, but let's check what error we have here. Okay, we run into an out of memory error. Okay, so I have to check how to increase the memory, but and I also will do some improvements on the way to load the data. I think that's also the problem because when I load the data, it doubles the amount of uses data because you have the data in the RAM by loading it from the JSON file. And then I have to store it, and this doubles the amount of RAM enormously. So I have to check this during the lunch, how to improve the data loading. So and for that reason, let me decrease that a little bit.
I have a small question or a suggestion. Could it be that in this case, if you work with tons of things, you need to have a more granular approach? So instead of creating all users and then saving all, basically do it in chunks and
yeah, that's right. That's exactly the point, because during the creation of the data, it doubles the amount of data on the server because it has to be the JSON file has to be loaded. Then I have to create I have to create a collection, and after that, and the JSON needs RAM, the collection needs RAM, and when I hand over the collection to MicroStream and store it, it takes another amount of RAM, and that's the problem. I have to find a more proper way to create the data, and that's the reason.
Maybe for now, seeing as you start the application in IntelliJ, I think it is IntelliJ, or sorry, yeah, you could just increase the heap size of the JVM to at least bridge this gap.
So I will check this during the lunch for you, and let's go on after lunch with the example. But just to show you a better approach of handling the data, I think that's more important for that example, to have this, and that will help to decrease the amount of the amount of thing. And there should also be a, give me just a second. There are some get persons by ID. That is what we need, but I tried to find. Yeah, you see that here. That is another endpoint I created to find a specific person with a specific last name. And that, I think that is important. So first I try to find the right chunk within the map, which is part. So that means I go to persons by last name, and then I go through the keys of that map and try to find the right element. So I will get only a small amount of persons which are part of that chunk of the map, I would say. And then I say, okay, if lazy not equals null, then I call lazy.get, so give me the data. And after that, I stream through all the results within that small list. And then that makes things much better. So let me just check this. So let's clear the data and just try it with those with only 200,000 person. I think that makes things better. So start. Postman. Person create. Send. Check this. Monitor. Okay, memory increases as expected. Okay, person successfully created. And now when we stop the application, it's the data is still loaded lazily. So when we now start it again, MicroStream or the application, let's do the init. I can do this via browser. %/init. Let's check the RAM. Okay, it's still low. And now when I try to load one person, I don't have to iterate through all the person. When I say, okay, find a person with the name Corin, I send this, I will get the person back. And you see the memory consumption stays low as it should be. And I think that is a way you should store the data. That means not only to use lazy on huge collection solves the problem. You have to deal with, or you have to provide a better data structure to use lazy in a proper way. I think that's the message behind the scenes. And let me try to find a proper way to load the data during the lunch. Okay, sorry for being late, but yeah, I had to double check some points of MicroStream. And then I tried to prepare, or I tried to improve the code several times. The only thing I achieved was to crash the Zoom meeting because I increased the amount of RAM, but my system does not have more than 10 gigabytes at the moment, because the Zoom meeting and all the other stuff needs also a lot of memory. So, but there are some interesting points now. Let me share my screen. So where is it? Dun, 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 dun. Okay. Need this. Okay, you should see my ID. We can skip this. We don't need that anymore. Okay. let's go back to the. So the idea was, it was such easy. The solution is quite easy because instead of increasing the amount of adding the amount of persons here, it makes more sense to click a few more times or to request a few more times that endpoint. That makes more sense than it increases not at once, and that makes more sense to do that. And this is I achieved an amount of 800,000 person now on the branch number 3 with the let me show you with this architecture. So that means we have 800,000 persons in that maps add of them complete. And when I start up MicroStream now, or when I start up Micronaut, you will see that most of the data stays on the hard disk. So let me initialize, or yeah, let's call directly one person or one specific last name. So let's search for a person. So you can see at the moment we have a usage of around 23 megabytes. Let's call for a guy named Koren, and this guy should be multiple times inside the storage. Let's send this request and let's have a look to the data. So, okay, the first call, it's the most heavyweight call, I would say, because Micronaut and MicroStream has to start up or has to initialize the storage and so on, and that needs a little bit. But in the end, when the data is loaded, and here is the result, so that means MicroStream startup time and query time are 16 seconds at the moment, and this is and 800,000 entries completely, but the Koren entries are, I don't know how many entries there are, but that is the result. And when we click again, we have 29 milliseconds at the moment to get the result. Something between 30, 29 to get these guys out of the 800,000 persons.
I would have a small question there regarding the performance, but this basically means that you just really get the benefit of MicroStreams if everything you're searching through is correctly loaded in the memory, right?
No, not really, because yes, of course, the huge amount of performance comes from the in-memory part. That's right. But there is another advantage. We don't have any mapping anymore. So so when we load the data from the hard disk, it's also faster than all the other stuff because there is no mapping in between. And I think that's also a big advantage.
Okay, and the second question would be, I mean, this sounds somewhat fine for smaller or medium size of content, but if you have bigger things, like, I don't know, thinking about tons of, for example, even though I'm not sure if it's applicable for MicroStreams, but thinking of tons of logging events where every user interaction triggers an event and you want to search for them, then you always get in trouble because of the sheer size, no?
Yeah, that's true. So let's talk about terabytes of data, for example. Of course, yeah, it's an in-memory database. That's what I said. It depends a little bit on the use case you want to use MicroStream. And that's also the reason why we are working at the moment on a second version of MicroStream. We call it the big data version, I would say. It will be available, I'm not quite sure about that, but at the beginning of 2023 or next year. and this is a big data version, and this is working a little bit different in the background. So that means that all the data will be splitted up at different cells and so on. And yeah, I would say that's the reason why we are working on a second version. But yeah, I think this version now is able to deal with data, but it depends on your data structure, basically.
Okay,
but you
thank
have to find a way to handle your data at your own. But I think, yeah, you're right when you say if you have terabytes of data, could be difficult. But on the other hand, there is another idea. So let's say how many, it depends on the amount of RAM you have. Because when you say, okay, we have terabytes of data, and on the other side you have, let's say, thousands, or how many concurrent user you have, it depends on the concurrent access to that data. Your application server has to handle a huge amount of RAM anyway, because multiple users, when you use Hibernate, for example, you have different caches and so on. The amount of RAM will increase anyway. So, and there is one big advantage, that every user or all the concurrent users are working on one data structure, on one object structure. And maybe the benefits are better than to have Hibernate caches, for example. You know what I mean? So yeah, you have to try it out and see how it works. And maybe it makes more sense to have log data on a normal, let's say, storage, and separate separate or split up the object model a little bit. So for nowadays, I think it makes even more sense to try to split up the object model a little bit. That makes the handling much more easier. And I would not recommend to have those big or huge graphs anymore. Try to split up and separate the data, and that makes things much easier. But it's up to you. Especially when you use microservices, you should split up your graph anyway. Okay, so let's have a look. How does it scale? So okay, now as you can see here, now we have 426 milliseconds again. That is because the garbage collection is running in the background. And when we now click, it's again on 28 milliseconds. Let's have a look to the RAM. Okay, it stays nearly the same. Okay, just stop this and let's have a look to the amount of memory we need. So okay, so let's stop this. Let's delete the data and let's change to the very first branch. And on the first branch, there is no lazy loading in place, just to see how many RAM do we need for how much amount of RAM. So let's start this. Okay. So let's monitor this. Okay, so let's call it, let's call the first package. Okay, the first 200,000 are loaded, and they will stay in the RAM. So let's call the next 200,000. Okay, and let's do this. Another one. Okay, now we have around 5 GB in the RAM. Let's do a small garbage collection. Okay, for the pure data, we have around 4 GB in the RAM. That is around 600,000 persons now. And what we can do is now have a look how big is the data basically on the hard disk. So let's have a look to the hard disk and check what is the size of the data folder here. Okay, we have around 4.73 GB of data, of person data, and we have a memory consumption of around 4 GB. But that is, that just to compare how many data are we able to store and how much RAM we need to store the data or to keep the data in memory. Yeah, that's the thing, I guess. But as I said, it's not necessary to keep all the data inside the memory. You wouldn't do that with other databases anyway. So, any questions so far? Any suggestions from your side to storing data or?
I would have one question regarding, are there any recommendations how to implement multi-tenancy in MicroStreams?
Multi-tenancy?
Yeah, multi-tenancy.
Okay, so based on the data structure side or on the application side?
Well, ideally on both sides. Yeah.
Okay, so basically on the data structure side, I would recommend to have a list of, let's say at the moment we have a data root and we have a list of persons, and let's imagine if you have multiple tenants, or then a person would be one tenant, I would say. So on the data structure side, it's quite easier to have multiple tenant. On the other hand, you have the possibility to add multiple storage manager, for example, or you can create multiple root objects. As long as you don't have any references through the roots or to another root, you can have multiple roots with one storage manager. I think that's the storage part. On the architecture part, I'm not sure if that is a part of MicroStream, but
yeah, let's say that's enough. Basically, if I, for example, create multiple root objects per tenant, then it will work.
I think that will do the trick.
Or maybe if I just create something like a map with the tenant as a key,
that's right.
Avoid to load everything from the memory.
That's right. Just use a map instead of a list, and then you can have multiple tenants within that map with a short description or some metadata, something like that.
Yeah, thank you.
Okay, so yeah, that's it basically regarding lazy loading stuff. I would go further if you're okay with that. And if there are no more questions, we have two more topics for today. One is the legacy type mapping. So what happened when data changes within my application? And the other one is how to create a proper backup with MicroStream. And I would say let's go with legacy type mapping. So what happened when data change? So let me just prepare the presentation. So I don't need this anymore. I have to clean up a little bit. Just a second. Don't need this anymore. So. And we need a project.
Christian?
Yeah.
I have a question related to some lazy loading because I'm thinking about some use cases in my head. So basically, if I have, for example, terabytes of data and I want to search them, so it's let's say in the worst case, it needs to have collections that are the most biggest as my RAM. So for example, I have collections of 1 GB size, and then I can, if I want to search through them for all of the elements, then I need to be able to load the whole collection to the memory and search it.
Oh yes, yes, definitely, yeah.
In a better case, in average, if I use, for example, map for such collection, then it will load only those elements that I directly fetch from the map. So I don't need to load the whole collection.
Okay, that is the example branch number 3, I guess, with those indexes in the map. Yeah.
Yes. Okay. And in other cases, it's if I need to, let's say, search the bigger collection, then I need to split it into the segments of, let's say, of some kind.
So I have to add something. We are working also, or we have a collection. We created a collection which is called a lazy collection. It's a second collection type or another collection type we provide with MicroStream, and this collection takes care about to load only chunks of load only a small amount of data at once from a huge collection. And this collection will be available in during the version 7, I guess. We are testing on that at the moment, but maybe that will also help to handle those data problems or such amount of data. So that gives you the possibility to stream through the collection, and only the chunks will be loaded and released again and again.
So maybe I can imagine it like a sliding window of the collection, and it will load it and drop it, through the scanning of the.
That's right.
Of the huge data.
It will be available during version 7. I'm pretty sure. Maybe on version 8, but will be version 8 will be released soon, I guess, during this year, I guess, or during the end of the year, I think.
And if, for example, if I use Apache Lucene index and build an index on top of the items, and hold the index in the memory, then
I think it's quite the same. Like it's quite. I think in comparison Apache Lucene versus MicroStream, I would say. I think basically they do a lot of things quite equals. You would also need a lot of RAM to use Apache Lucene. Of course, you have to keep the index in memory, but it's kind of like the same. You have a map on the Java side. Yeah, I think there are some similar things in comparison the two technologies.
It's like better API for the searching, for example, tokens or something. But basically, it's the same.
Yeah, maybe. Yeah. Maybe they are more flexible to search some, but I think you have to find a good how to say yeah, I couldn't find the right words for that. How to say again, I can't get the right word for that.
Balance.
People ask us that a lot. I said, come on, what's wrong now? When to use MicroStream, how to say that? What is the best approach to use MicroStream, or what is the use case? That's the right word for it. Yeah, you have to find the right use case for using MicroStream. And we used MicroStream a lot in small and medium-sized projects, and that works really great. I don't know if MicroStream is the right technology for such huge databases with terabytes of data, but maybe yes, because some data needs to be stored in memory. And if it's only a part of a huge database, then it's okay. You will get the data in a very fast and performant way, and you can store it there. Maybe it's just a solution to run beside a huge database like Oracle or SQL Server or something like that. I think you have to find the right use case for MicroStream. And I think that's the point. And in some cases, you have to consider that there is a lot, you have to handle the data anyway. With thousands of concurrent users, maybe you have to have that amount of RAM on this application server anyway. So yeah, and maybe then it's okay to have you can see if you have a look to the cloud services and so on. I think what is the biggest amount of RAM you can order on AWS? It's around 64 terabytes at the moment, or I guess more, 200 terabytes at the moment of RAM. Especially for SAP HANA, I guess you will be able to order 200 terabytes of RAM at the moment. It's the maximum, I guess. And yeah, it's the question is, why not to have such a huge amount of RAM to keep the data in it? Why not? If you need the performance, you have to do that. Otherwise, you would order many people have, okay, we have the database, and because the database is too slow, we need to order another Apache, not a Lucene, let's say, what is the Elasticsearch server to cache the data there, and this server also needs a lot of RAM. Yeah, maybe it makes more sense to do this directly on MicroStream, because you need the RAM anyway, and you have to pay for that anyway. But the effort to implement or to handle your data is much better, because no mapping anymore. You can use Java. not any other technologies. But yeah, you have to find the right use case, and I think it's up to you to use that. Okay, is that okay for you?
Yes, it is okay for me. Thank you.
Okay, so legacy type mapping. Let's talk about what happened if your data changes. So let's do that. So let me share the, no, I didn't share that. So let me share the project URL. Okay, this is the project on GitHub we are working on. And okay, the first question we have to clarify is, how does MicroStream handle data types basically? And what happened if we do some changes in the entity? That's the biggest question. And what changes can be handled automatically by MicroStream, and what has to be done manually? That is this topic is a quite huge topic. When you go to the documentation of MicroStream, you will see tons of text and descriptions and so on. But I think the first step of the legacy type mapping is quite easy to understand and not that confusing. Okay, how does MicroStream handles data types? And we already seen this part, that is a part of the persistent type dictionary, and we've seen that every type which is used within MicroStream, another type or another entry will be created within that type dictionary, which contains the object ID, or let's say the type ID, which is this one here. This is the type ID, and then we have the Java build path of the object and all the included fields and so on. And as I said, the storage could look like this in a way, and you have blue and red entries there. And it's important because every entry here in the storage has the marker for the type ID in. And that's the important thing. When you miss that entry here, you will no longer be able to start the storage. And that's what I'm talking about when I said, okay, take care about your persistence type dictionary. Okay, each entry in the storage has a type ID and an object ID. Each type in the storage has its own type entry in the dictionary. That's what I said. Yeah, that's also the same. When the type is missing, the storage will not start. Take care about your persistence type dictionary. But yeah, normally I think that's also nothing special. Just try to delete some files of your Oracle database in the background. If you're able to do that, it will lead to the same disaster, I'm pretty sure. Okay, what data types are supported? So basically, most of the data types provided by the JDK. And there is also a list in our documentation. Let me just check this, docs, and there is layered entities, logging, wrapping. Oh. Where is it? Here it is. Supported Java features. Let's have a look to that. I think most of the data types are handled or covered in MicroStream. Java 5, Java 8, Java 14 records are supported. Java 17, immutable sets, immutable lists are supported. I think most of the JDK supported data types you can use with MicroStream. And there are some special type handlers already in place. All these type handlers are covered. Neofile, collections, all these collections are covered And it might be possible that you have to add a special dependency for JDK 8, for example, to use special features of the JDK 8 or use special features of the JDK 17. That might be you might have to use this maybe when you used the immutable set and the immutable list. Okay, so let's go on. Yeah, what happened when we add a new attribute to a customer? So basically we have an ID, last name, first name, male, and gender, and let's add another field to the customer. What happened in the background is that we will get another entry with another type ID, which is, in that case, we have the old one is 66, the new one is 67. And at the beginning of MicroStream, we thought, okay, let's convert all the existing types, all the existing data, simply to the new version. But the idea we could not realize that idea, because then we were able to load all the data, and let's imagine when we have thousands of rows, we have to load and store them again and again, and that's not that won't work. So, and based on that, we had the idea, okay, let's do in kind of like a versioning. So that means when we create or when we start the application, and every time you touch an old one, it will be converted to the newer version. And the important thing is to touch an object is not enough. You have to store it again. So that means you can read the old ones. That's not the problem. And but you have to store them again to convert the object to the newer version. So, and this is how it works. Or give me just a second. Maybe touch is enough to load it. I think that's enough, but let's check this. Okay, so during the work with the object, that will be automatically converted to a newer version. And that is how it works. And in the end, during the work, every object is updated, and then you will not longer need this one. But it's not needed to delete it. Just keep it in the persistent type dictionary. It's totally okay to have that. Okay, so as I said, it's kind of like a versioning. Every time you touch an object, it will be converted to the new version. Let's say, so basically, adding, removing, and moving attributes is not a really big deal. That's, yeah, quite that will be handled by MicroStream internally, and you don't have to do anything. But let's see. There is a heuristic working in the background of MicroStream. Let's say we have, for example, these are changes we made in that class. And let's say, okay, we have the string name, and string name is, yeah, it's renamed to last name, and first name is moved. That's the reason first name is on the second place. Now it's on top of the class. Then we have the name. Name is renamed to last name. The age is moved to the end of the class. The email is renamed. Node is renamed, and postal address is a new attribute. So all that stuff can be handled automatically by MicroStream, because we will see that in an example later on. The heuristic calculates a value and tries to do the right thing most of the time. So this is what the heuristic looks like. So when you start MicroStream with a changed class, for example, here requires for legacy type, we have the old one, it's 55 contact is the current type, 56 is the new one. And now it calculates values. So for example, first name, okay, it's I would say it's 100% the same same element. Name and first name, he decides based on the data type, on the name, and on the position inside the class, if it's the same or not. And in this case, he decides, okay, name is mapped to last name, so because only the name changes, and that's okay. The same for email address. For node, this is much more complicated, I guess, because node is totally different to that what we see here. But yeah, in other way, it's a little bit similar. Then we have the age. It's moved to the next one, and then we have the link. That would be the postal address. That was the new one, which is added. Yeah, and that's it. And this is how the heuristic works. And this is the heuristic that did a really great job. And most of the time, it's quite easy to handle that. Best practice. So let's talk about how you should do things during the development. So when we are able to delete the storage again and again, you should not use the legacy type mapping that much. Just delete your storage, create some good mockup classes, and use a new storage again and again. As it is, use some mockup classes and to get a nice and clean storage on startup. Don't use or don't change multiple attributes in one class. So that means I would recommend to do this step by step instead of doing them at once. Of course, you should create a backup. I think that's quite normal and should be natural. And these are the important ones. Data type changes, for example, in most of the time there is a special migration necessary. So, for example, if you want to, let's say we have an integer value and we want to change this to a string value, then of course you have to add some migration business logic behind the scenes to move the value to another field. And this is also the way you should do. Just create the new attribute when you have to, then start the application, do some business logic to copy the data from one attribute to another. And after that, shut down the application and remove the old attribute. That is the best, or the best practice we recommend to do some critical changes within the data model. And this works really great most of the time. In some parts, and I think it depends a little bit on the status of the project. So when you are in the production, the data types or also the structure doesn't change that much after production. And if yes, then you have to do some migration stuff to a new storage. But everything is doable, I would say. Let's jump into the project I created to see that on a live system. So let's start on the master branch. That's okay. So we had a controller and we had an object which is called author with male, first name, last name. So let me just check. There is no data in it. Let's start the application. And I think there is only one. Let's use the creator here. So let me create localhost 8080. Then we have, what is the authors /create. So this is again, what is the problem here? Authors .create /create. That is, I don't understand why is that. Post 8080. So I had that problem also in the project before. Just a second. Let me just restart the IDE. Okay. So legacy type mapping, we have the application, authors, controller, create. Okay, give it another try. So now let's say authors.create. No. So I have to try this with the postman. I couldn't find the reason for that. Add request, get, so there's localhost, author create. So we can do this together, then you can see what I see. So let's say HTTP localhost 8080 authors. Just double check that. Authors, yes. Let's say create. Okay. What's going on there? Switch the branch. Okay, mail author, first name. Let's try to start this. It's the same, create. Okay, this is working. Switch back to the master. That is really weird. So, okay, I have to switch the branch. Maybe a Maven update will do the trick, but yeah. Okay, so let's continue on the browser. So as I said, so I created an author. It's only one. And as you can see here, we have mail, first name, and last name. And that is the same result we have in the object itself. So we have the mail, first name, and last name. And now we change, we keep the storage. The storage is here. It's the data here. We have multiple channels and so on, but we switch the branch. And within the next branch, we have different names for that. So let's switch the branch. Switch to, these are the next branch. And you can see here, the names of the fields are different. So we have mail author now, first name stays the same, and we have name, the last name changed. And let's start that project again. Run this German application. Let's call the authors. Let's do a refresh. And now you can see that is the result. It says, okay, there is a new one which is called author. This is the old one. The 70 is the new one, and he recommends that, okay, male and male could be the same. 70%, I would say. Then first name stays the same, first name, and last name is changed to name. 75%, around that. Then you have to accept the mapping. Let's say yes, and then it's okay, and the data or the application starts up, and now you can see also the values are different. So now the values are, or the name of the fields has the same name like the new class. So, and that means totally everything is totally fine. MicroStream migrates the data automatically to the new version, and most of the time it works like this. So when we were also able to add another one, so let's say, okay, let's add private string or private double. Private double author, let's say weight, for example. Let's do this. It is, let's see what happened when we do things like that. Let's create a get and set method for that. And let's start the application again. So let's refresh. So we should see another. It recognizes that there is a new field, which is a double field and has the name weight. And let's say yes, it's okay. Let's do that. And this is what I said. So we need to save the element again to get the right result. But maybe we can, let's do something like this. Let's say create another one. And let's see. Yeah, now we have the weight available. There is only one. When we create a new one, it deletes the old one. But yeah, that is totally fine, I think. Any questions so far to the mechanism or how to handle data type changes or class changes? Anything from your side?
When you have something in production and you change this data,
yeah,
then how do you do this? By starting the instance by the customer from your side, or how do you solve this?
It depends on how heavyweight are the changes are. Sometimes we do that on startup. We create a backup before, or we copy a backup from the existing storage, and then we do all these things on startup. But when we have real heavyweight changes, then we create an offline copy on of the storage and do all the changes on the copy, and after that we switch the storage in the end. But I think there is no best practice, I would say. It's also up to you to handle these files, but most of the time it's enough to say, okay, let's do a backup and let's do this on startup. It's not necessary. It's not necessary to accept this. This is only the reason because I added. I added this to the instantiation, and when we remove this, it will do the update automatically. So it will not ask for a yes or a no. Let's do another change. Let's create another one. Let's say wait 2 with 190 whatever. Get and set methods. Let's start this again. Call this again. And as you can see here, it did not ask for a yes or a no. It migrates the storage automatically. And sometimes it makes sense to do it in this way, that we create a copy from the existing storage, check if the update is working great, and then keep it as a backup, and then do the stuff on startup, for example. Many different possibilities in that case.
Okay,
but
thank you.
I think there are no big differences to all the other databases. For example, when you want to change a data type, for example, within a relational database, you also have to do some migration business logic behind the scenes to handle the data. I think it's the same. Okay, some more questions. So then I would say let's do a short break, around 15 minutes. And after that, we do the last two topics, the backup section, how to create proper backups. And so I forgot something to say or to mention regarding the legacy type mapping. So I have to add something. Let me share my screen. The question was, what about explicit mapping? So basically, this is a part of the advanced. This is part of the advanced training, and that's the reason why I didn't mention it. So just let me add the chat. Okay, so explicit mapping. Yeah, it's possible. Let me just show you the documentation for that. So legacy type mapping, and you can see that here. That is the basic description, automatic mapping. But there is a second type of mapping strategy, and it is called the explicit mapping. And for that functionality, you will be able to add a document which looks like this, refactoring CSV file. And with that CSV file, you will be able to set your, or to configure your mapping, to say, okay, this is the old one, this is the old attribute, and this should be the new attribute. And especially in our example, I implemented that on the third branch. So we are on stage 1, and when we are able to start the application, so run as Java application. So let's create. I just call it on the second screen. So let's say localhost 8080, and it was authors, and create /create. Okay, author successfully created. Let's have a short look. Okay, looks like it should. Okay, and now let's say, okay, let's change the branch to the next one. Let's say team, switch to the other stage 2. This is an explicit mapping. So let's have a short look to the code. I think the important one is that stays the same, but there is one special thing. There is persistence refactoring mapping provider, and provide mapping. And for the mapping part, the refactoring CSV is in place. You can find it in the third or in that branch in the resources. And here you can see, so the idea is to say, okay, the field mail should be mapped to the field mail 6. Let's have a look to the class itself. So let's have a look to the author itself. So for that reason, I created some more fields. That makes no sense, but just for training purposes. And I want to add the mail value or mail author value to mail 6. And this is what it is defined in the refactoring CSV. Let me just check. Oh, the name is mail author. So this should be the right one. So, or just open this in the open with text editor. Yeah, now this should be the right one. We have the name is mail author and it should be mapped to mail 6. So let's check it out if this is working. Application run as let's refresh. Okay, we have new. You can see that here, mail 2, 3, 4, 5, and mail author is mapped to mail 6 as it should. And when we now have a look to the call, it looks like it should. So we have mail 6. It's no longer named mail author. It's mapped directly to mail 6. And there is another stage, another extended stage to handle those legacy type mapping stuff within MicroStream. But that is really part of the advanced training. But just to answer that question, there is a way to handle the mapping explicit. You can do that via a refactoring file. Okay, any questions to that explicit mapping? Okay, seems not. Then
if you have there now the mail 6 already, and it comes again to this refactoring, or every time you start, now it goes to refactoring to search for mail 6. Or
as long as there are still data inside your storage which are not transferred to the new version. So maybe sometimes we do this, so we load all the old ones on purpose, so to move them to the newer version, and then you can skip that message, so you won't get this message again, because the old data type is gone in the end.
Okay.
Okay, good. We had another question, and I think that's also an important one regarding the performance and about the memory consumption of MicroStream. The point was, is MicroStream only faster than when it's in memory? And I have to show you the performance demonstration again. And this is a comparison between PostgreSQL and MicroStream without using in-memory aspects, and also, of course, without using some Hibernate caches and so on. And these are the differences. So Postgres isn't using any cache anymore, and we have compared to that 800 on the MicroStream requests per minute, and this is also working without lazy loading. So that means MicroStream is not only faster because it's in memory, it's definitely faster because of the different data structure and the point that we don't need any mapping anymore. But yeah, just to add this, it's not only the in-memory aspect, it's also the mapping aspects, I would say. Okay, let's move on to the last two topics, the backup topic. And this is, in my opinion, this is also really important to know. And it's also a great topic. There are two different backup strategies in place. Just let me check if I have a presentation for that. No, it's not that complicated. Okay, so the first backup strategy we have is the concurrent, not concurrent, let me just check in our documentation. Storing data, configuration, backup, continuous backup is the right one. So the continuous backup, that means whenever you write down data to the storage, a second mirror of the storage will be created on a separated place. Could be on the same hard disk in a different folder, for example, but could also be the case that the normal backup is on a persistent volume, for example, and the mirror is, for example, on AWS S3 bucket. To configure that, it's totally up to you. So, and just have a look how to set that or how to enable that mirror. It's also quite easy. Let's have a look to that example, and let me share the GitHub repository. I don't need that anymore. Okay. Backup strategy, here it is. Here's the URL for you. Okay, that's the project. Let's have a look to the basic structure. Okay, no folders so far. We have one application. We have one domain object book. We have a book controller, which is, of course, it's needed. We have the data root here, just a list of books. Yeah, a really simple project. We have the configuration is based on an XML file, and yeah, really straightforward. We have that 1,000 times before. Let's have a look to the MicroStream XML. We have channel count 4 and store. Yeah, as always, it's the same. Let's move on to the first backup strategy. So to the first backup configuration. It's the continuous backup down branch. Okay, so we have the same configuration in the Java file. It's yeah, it's totally the same, but what changed is the XML part in this case. So there is another property which is called backup directory, and I said the backup should be part of the data folder, and there should be another folder which is called backup. Let's try this. Run as Java application. Just have a look to the book. Yeah, there is only one book controller, small localhost. Hopefully this will work for the first time. Books and create, right? So yeah, books/create. No, it does not. So let me just change the branch, or let's do a Maven update. Maybe that will do the trick. Maven update project. This might help. Try it out. Yeah, so it says book successfully created. Let's check this out. Okay, you can see that here we have just smaller books, ISBN, name. That's all we have, but it's working as expected. And the interesting part comes when we have a look to the data structure here. And as I said, there is a second folder here which contains the same structure twice. And this is the continuous backup. And that means whenever we write down data to this one, it will also be written to this one. And I think that's the first step to have a proper backup strategy. And as I said, you will be able to store the backup also to different other store targets. I think that's a great benefit to have that continuous, or sometimes we call it rolling backup. So because it's kind of like a mirror or a mirror backup. Okay, that's the first step to do a proper backup with MicroStream. Any questions so far? Okay. Let's have a look to a full backup. So what about a full backup? Have you an idea how to create a full backup of MicroStream? Some people say, or some trainees say, okay, we'll just take the whole data folder and copy it via some tasks, or just copy the data folder. What do you think? Does that work, or would that work?
Sorry, but I don't catch the topic about backups.
So the problem is when you try to copy the data, that could work, but when you are unlucky, then the storage stores things during the same time you create a copy. So in the end, you will get half of the last written requests, I would say. So that is a point. You shouldn't do that. You don't copy the data. So, and that's the reason why we provide a full backup mechanism. And this is also quite simple, or really straightforward, I would say. So let's go back to the backup itself. Oh, that's the wrong one. Yeah, that is the continuous backup. We already talked about that. As you can see here, to set the backup directory, this could also based on the Neo file system. And when you remember, the AWS S3 example I showed you was also based on that file system. So, and that enables you to store the backup also to the AWS S3 bucket, for example. But I think it's not possible to realize the backup via XML file. That could be a limitation to the XML file. But in this way, it works definitely. So, but let's talk about the full backup. It's just this line of code to create a full backup of your storage itself. And the special thing is, this is part of the queue of the internal queue of MicroStream. So when you use this one, it ensures that you will get the full backup, the right full backup, I would say. Let's go to the next branch to check.
Sorry, can I maybe just drop in for a second? I was wondering, so with the continuous backup, is there any implementation of back pressure or something like that? Like seeing how, depending how many requests I have coming in, that basically the modifications of the object graph are faster and the committing to the store than the backup. So is there any back pressure built in, or?
Okay.
Yeah, how is that handled? Thank you.
Maybe there is no feature in place to realize that. Maybe it would be a good idea to make a feature request from your side, that we can maybe do some built-in stuff for that or some integrations for that. I'm not sure if I get it right, but it seems to me that there are some other tools to improve the backup, right? So what was the name of the tooling you said at the beginning?
Me.
Web. Yeah, you said something about web pressure or web.
Back pressure. So basically, if, let's say if the writing to the backup that you want to do continuously is slower than the modifications or the modifications that are committed to the file, to the original file. So yeah, how is that handled? So basically, let's say I have 10 modifications per milliseconds that are committed to the original file, but the continuous backup can only write 5 changes per milliseconds, for example. So what happens to the other 5? Are they queued or?
That is definitely an expert question. So I'm afraid I have to forward this to Florian. Maybe he can answer that. But so basically the backup thread is a different thread to the normal one. So this thread would not block the existing one, and I'm pretty sure the data will be queued in that case. But yeah, I have to forward this question to Florian.
No worries. Thank you very much, Chris.
To answer that. So let me take a note for that, I think. Okay. Okay, got it. So I will try to answer as soon as possible. Can you just give me your name again? So what was your name?
Stefan Hansberger.
Stefan. Okay.
Thanks, Christian.
Okay, so okay, let's go further with the full backup. Just let me delete this one. We don't need this anymore. Let's change to the full backup. Oh no, that was the wrong one. Plus remote full backup done. Okay. Let's check it out. What happened? Okay. As you could see, it's only this small line of code. So to write down a full backup, it's not really a big deal. But you have to find a solution to write down within a Quartz job to do a backup every night at 12 o'clock or 3 times a day or something like that. And for that reason, normally we use the Quartz scheduler. And it's the same in this example. So we created, so basically we created, let me just check. There is one, So there is a Micronaut event listener. That means whenever Micronaut starts, it initializes and starts the backup scheduler. And this scheduler in this case, sets the backup every minute, I guess. That is the scheduling part for, let's write down a full backup every minute. That makes no sense, but it's just for the training. And in the end, we have the backup tasks. The backup task, it's this one. No, not this one. Come on, this one. Yeah, and that is what I've said. Storage manager, issue full backup, and then you have to define the file system where you want to write these backup. And in that case, it is written to full backup, or it will be write to full backup.data. So let's check it out if this is working as expected.
I have one question. Is it also possible to create incremental backup or something like a snapshot?
That's a good question. An incremental one, basically yes, but you have to do it by yourself. Especially within here, you will be able to create some, let's say some data folders with different timestamps behind, like that, and just say, okay, let's keep the last 6 backups for, let's say, a daily backup. Let's keep 5 daily backups and one weekly backup, for example. But this is not part of the MicroStream framework itself. You have to create this by yourself via Java code.
Yeah, and those backups are full backups. Yeah,
it's a full backup all the time. Yes.
Yeah.
Yes.
Okay. Thank you.
And for the other purposes, maybe it's the incremental one or the continuous backup. You can run both you can have both backups in place. So do this one every week, for example, and use the continuous backup as a daily backup, like I said. So there are many different possibilities, but yeah, it's not a built-in function for MicroStream, but it would be a great feature. Maybe. Yeah, let me take a note. Maybe we can improve that that strategy a little bit. So, improve backup. Okay. Good. Let's check if that Quartz job is working. So we need the application. Here we are. Set run as Java application. Okay, so let's see. Quartz job is running locally. This startup. So let's write down some books/create. As you can see here, the first backup is successfully done. Let's have a look. Here you can see the full backup, and here is the data, and the backup is written to the full backup. We can delete that backup again. Let's wait for the another try. One minute can be a very long time. especially when you have to wait for it. So, okay. So, and as I said, this is the full backup and the full backups strategy, I would say. Yeah, that's all about the backups. Any questions? So it's not that complicated. And I think this is one of the biggest advantages of MicroStream, because it is easy as it is. Yeah, that's how the backup works.
Christian, I have a question related to full backup. Does it mean that it covers data, or if somebody writing during the full backup, does those writes will be covered also in the full backup or not?
Yes, they will be covered. Yes, but so let's say the full backup is part of the queue. So when all the writing requests after the backup are not covered, of course, but it's part of the queue, and it's consistent, I would say.
So if I understand well, so those objects in the graph are queued, and once the object from the queue is backup, then it's written, and the changes after it are not backup. But
yeah, that's right. That's
object is still in the queue waiting for the backup, and those changes are written, then this will be backed. Okay.
Yeah, but of course MicroStream takes care about to keep data consistent. So it's basically it's not possible to write a child element to a parent object maybe anyway. So it has to be consistent, and maybe the parent object no, that will not be the case. So because when you add a parent object with a child object, it's one store. It is a one store command, and this store command will be stored as once, I would say. So that means that the parent object is available, also the child object. But after that, then the full backup is running, and till all stores till that backup will be covered, and of course the following ones not. But I think that's also quite normal. Or what is your expectations about that?
I'm just thinking about expectation. If it's a snapshot for the specific timestamp, the whole graph will be back up till the timestamp, some kind of lock of the graph which will be back up, or let's say like continuing the backup of the graph. So if there will be some updates during the backup process, then how it will behave. So if it covers the changes or not.
You think of to only have a backup of the changes, right? Not the whole.
It depends, but if I, let's say, for example, restore the backup from the specific timestamp, then what I will get?
Yeah, I see. Okay, got it. So I will take an additional note for that. Improve backup strategy and how, so that enables you to restore the data at any time, right? So to then this would be covered by the continuous backup, right? So the continuous backup or the mirror would do the trick in that case. Or the continuous backup enables you to restore at any time, but not at a specific timestamp. Yes, I think that's the case. Okay.
Because if I execute the backup every 24 hours, then what will be covered? Let's say if the backup timestamp of midnight, then does it contain the changes that comes during the backup itself, or when the backup starts?
That is a kind. It would be the same like Git do it, or like Nverse. Or, yeah, I will take that with me. Maybe that could be a feature for the future.
Okay.
Okay, got it. So, okay, we talked about backups. Some more questions from your side. Backups. You have that basically, that's okay. So, okay. Yeah, there is one topic left, and this is, yeah, only a small topic. And it's about the best practices of using MicroStream. And there is a lot of stuff we already talked about, but I think it's important to know before you start with MicroStream. Let's talk a little bit what should be the case during the development. We talked about the backups now, but I would recommend you to avoid enabling the continuous backup function during development, because as we said, in some cases you have to delete the storage, and then you forgot to delete the backup, and then the backup, or especially the mirror or the continuous backup, has a different status than the original storage itself, and you will get error messages. And I think basically when you know, oh, okay, I see there is something wrong, and oh, I forgot to delete the backup, but many of our customers couldn't find the right solution. Why is the storage not working anymore? And they couldn't find the problem, and they called us and say something is wrong, the storage doesn't work, and so on. And then we say, okay, there is a backup configured, and the customer forgot to delete the backup also. And yeah, that's the case. So from this best practice part, don't do a backup during the development. You will not need it during development. Create a proper mockup strategy. That is also a huge point by using MicroStream. The biggest problem of our customer is the point that they said, how can I see my data? Where can I see my data? Is it possible to have a data backend where I can see the data, or where I can edit the data? So basically, that is not possible. So you have to take care about about possibilities to make your data visible. For example, create some find all endpoints, something like that, just to see the data. There is one possibility, but I don't want to get into it now. Because it's not the best. Just a second. MicroStream. Couldn't find it. So MicroStream documentation. REST interface. Okay, here it is. So there is a REST interface in place. This is also documented here, and this is it's also working. But we are still working on this to create a proper solution for that. So basically, you are able to enable a storage REST service, a Spark server, and this starts all the time when you start MicroStream itself. But this is only for developer purposes, not for using it as in production. Then there is a client UI and a small application where you can connect to your storage, but the storage must run at this time. And then you will be able to see the data within your storage with the object IDs and so on. And this could be quite helpful to see the data and to see all the statistics and so on, the total size, the live data size. This is already in place. But as I said, we are still working on that to improve the functionality of that interface. And yeah, to be honest, I did so many projects now together with MicroStream. I've never used that REST client in the end. So for me, it's not that important. We are working on an improvement, but yeah, you have to take care. Just create small endpoints to see your data and to see what happened within your storage. And yeah, I think it's much easier to deal with your Java classes and to see how the structure is. And for that reason, I think it's important to have a proper mockup strategy to stay sure whenever you start MicroStream with an empty storage that are basic values in place to develop with them. And yeah, I think that's important to have a good mockup strategy. I already said this, don't use explicit type mapping during development until first production system is up and running. I think, yeah, that's quite normal, I would say. And after that, I would recommend to use explicit type mapping after your first production deployment, because that makes sense to have that. In some cases, yeah, when you have small changes, just for example, when you add another field, for example, then you don't have to do that. But when you want to ensure that things are well mapped together and something like that, you have to use the explicit type mapping. Use environment variables for most of the properties. That I think that's also quite normal in the Java. Use environment variables whenever you can, or some system properties, that is up to you. Create a proper exception handling for database write exceptions. There is one topic in the advanced training which covers that exception handling part, because there are some, let's imagine you have a Docker container or a pod on Kubernetes, and you have a persistent volume connected to that. Then the question is, what happens when, for any reason, when the persistent volume is disconnected during writing the data? I think that's the worst case, what could happen, basically. Then you have to take care about your storage. And that's important to add a proper exception handling. As I said, it's part of the advanced training. Yeah, and that's also an interesting point. Keep in mind, you change the memory in the background. That means when you write down values to the memory, all the other concurrent users will see these changes immediately. That means when you change the RAM, all the other guys have those changes. But what happened in the end when the data isn't stored? And the worst case is that you will not notice that the data isn't stored until you do a fresh restart of the server, because then you will see that the data is missing because it's not fully stored on the hard disk. So, and for that reason, it's important to create a proper exception handling. Yeah, that happened in the past in one of my projects, and that was yeah, quite annoying, I would say. For that reason, you also have to implement a proper rollback strategy, and this is also part of the advanced training, especially for the case I explained to you, when the persistent volume maybe is disconnected or something like that. or you have or you changed the RAM and you will not be able to store down the data, then you have to roll back your data. There is a mechanism within MicroStream which enables you to roll back the data. But let's talk about that in the advanced training. Avoid concurrent access. I would say this is one of the most important and also the most interesting part of using MicroStream. The point is that every concurrent user is working on the same data model, on the same data structure. And this is the point where you are forced to handle concurrencies. Mostly when you use Hibernate, for example, you don't have to care about concurrencies because it's one user session and the data is yours, and the data you handles only copies of the data. And that is the reason why you don't have to deal with concurrent accesses, especially with Hibernate. But with MicroStream, you have to, and you have to try to find, or you have to find a solution for concurrencies. A concurrent or a proper concurrent strategy is also part of the MicroStream advanced training in the end. Let's have a short look to our roadmap and what we are working on. So basically, we are really proud of the version 7 at the moment. Version 7 is, I would say, one of or the first most stable version we have now. It starts on version 5. I would say version 5 was a great MicroStream version. 6 and 7 are even more stable than version 5. The version 8 will contain the lazy loading collection. This will be a great step to have that. And yeah, as I said, we are working on a replication cluster at the moment. That means, yeah, how to explain that? You have to imagine if you want to have a Micronaut application as a storage provider, then you create your Micronaut application and you add MicroStream in it, and you add some endpoints, some store endpoints and read endpoints, for example. And the idea is to hand over that Micronaut application to our service, and we take care about clustering this Micronaut application. So that means we built, there is an existing infrastructure behind the scenes, and this infrastructure replicates your application in a way that you have one writer application and let's say 5 read applications. And whenever you write down data to your to the cluster, it will be replicated to the read nodes. The replication of MicroStream is a feature which is not available at the moment, but it's a really powerful feature, and it will be available with the cluster at the same time. And this is why we are working on the replication cluster. This cluster will be based on Kubernetes, and yeah, it's quite interesting part, but yeah, we still have to work on it. As I said, we are also working on the, let's say, big data version. I call it big data version because it enables you to handle much bigger objects or much bigger data than now, maybe. Yeah, but as I said, it depends on the data structure. You can also handle terabytes of data with the nowadays version, but it depends on the data structure itself. But with that version, it will work better, I would say. And this big data version will also be part of the replication cluster in the end, so that we get this feature also for the replication cluster. And in the end, we will have then a big data cluster, I would say, together with MicroStream, that will be a great benefit for us and for you guys. And yeah, I think that are the most upcoming things for the next few months. Yeah, any questions so far to that? There is another question in the chat I have to answer, but first I have to read this. I just out of the context and just learned that you're using graphic clips. Okay, then there's one question regarding my IDE. Basically, I worked a long time before I started to work for the company XDev. I'm not sure if you noticed XDev, but XDev creates an IDE which is called Rapid Clips, and Rapid Clips is an Eclipse distribution with some more plugins in it, and it's especially designed for creating UI projects. So that means so let's say let me just create one example project. So let's create a project which is called then. Let's do an app layout, and it creates a basic Vardin application. So you will get a web application in the end, and it's, yeah, I would say it's a rapid application development stuff. So yeah. What is the new word for some applications or some IDEs like that? Yeah, codeless or something like that. So, and as you can see here, it creates the application itself. And so let's add some server, the server's top. There is no Tomcat in place. Just a second. Let's use this one, Tomcat 9, finish. Yeah, like Java FX, but just for the browser, I would say. So now I created this application. Let's move it to the Tomcat, start the Tomcat, and oh, now it's quite hard to type the name of the application. Let's say localhost. What is the name? FDG and DFG. Okay, let's see. Now you can see this is the application I created a minute ago. It's a rapid application development IDE, and it works also for Micronaut, and I like Eclipse a lot. And I've never used IntelliJ before, so I tried it, but yeah, I like Eclipse more than IntelliJ. This is the application itself. Then you have some tabs in it and some stuff like that. Yeah, that is the reason why I use Rapid Clips. And we created a lot of applications like this on this IDE, and that's the reason why I'm working on that IDE. That's all. Try it out. It's a great IDE, and it enables you to create quite fast application, also based on. So, for example, we have an example database in the background. It's an H2 database, but just a second. There's the data source explorer. Yeah, you can see here, this is the car migration project I created. It's a PostgreSQL database. And now let's say, okay, we want to connect this database with that project. So I'm able to add a data source to the project. Let's use a JPA data source. And you will also be able to add a MicroStream data source. Let's use the JPA one. I have to add the JPA facets and so on. And now I'm able to choose the core migration database, which is a PostgreSQL one. And it imports all the tables. So I'm able to choose the tables, the company, customer orders, and so on. Say next. He takes care about all the constraints, and the IDE creates a complete Hibernate mapping based on the database itself. So you have the domain objects here, you have the data access objects here, and you will get, in the end, you will get a project with all the Hibernate annotations in it, and then you can say, okay, let's add just a second to open the UI editor. There is also a UI editor in place. Let's wait a little bit. The server has to be started in the background. Ah, come on. So the package manager needs a little bit when it runs the first time. So come on. Oh, okay, here we are. So, and now you can add some UI elements. Oh, I just need the panel. Or what is the is it named? Palette is the name. Okay. So now we have a palette here with some UI elements. Let's load it. Okay, here we are. So now you can add a button, for example, or you can add a grid. Where is it? And the special thing is now to do the data mapping to the grid, you can take the domain object here, for example, the customer object, and put it via drag and drop on the grid. And then you will see all the fields of the entity, last name, first name. Let's add the company name to the grid. And in the end, you will get a grid out of that, or you can also you are able to drag and drop the customer to an empty space, and this creates a form for you. Yeah, a lot of different stuff is possible in that IDE. And in the end, you will get all the form elements. And the special thing is that everything in the background is pure Java. So when you see the project in the end, without this IDE, you would not notice that it is made via, yeah, it's free, definitely. Check it out. And everything you can see here is just pure Java code, nothing special so far. Yeah, okay, let's go back to MicroStream again. So are there any questions to MicroStream or regarding MicroStream?
Yes, I have one about, you mentioned that there are other applications in clusters. For example, if I have one application that stores data into the repository, and this repository will be shared with other application, and it will be used by, let's say, lazy loading. And if it, for example, load the data into the memory, use it, and first application that write the data, write a new version of data, how the read application will be noticed that it should reload the data from persisted cluster.
Okay, basically, so I'm not aware of all the stuff, how the replication works, but basically there is a message provider in the background, could be Kafka or IBM MQ. And whenever you write a data to the normal, to the writer node, it will send, or it will, this node forwards the information to the message broker. And the message broker takes care to notify all the existing reader nodes and adds the information to the MicroStream storage on the different pods. The point is, the important point of that cluster is that every replication has its own storage and has a full storage, I would say. So every cluster part has its own working storage, and that makes it possible to add the data behind the scenes. And that is also a reason why we are working on that big data approach, I would say, and that enables us to have only one storage, and many different replications can use this storage at a time. That, I think, that is the biggest advantage, and one of the biggest advantages of the big data solution. Yeah, but let's see what's coming next, and I hope that answers your question. Not sure if I get it right,
that each node have its own repository, and when you want to replicate new data, then it needs to be handled by the application, like some Kafka broker or something.
Yeah, right. That's
so
right.
It doesn't done by the MicroStream natively.
So the basic functionality is based on MicroStream functionality, but to handling those messages, it's made by a message broker, yeah. Because that message broker is also, let's say, it's also kind of like a backup, because it contains all the messages. And whenever you want to create another pod with another reader pod, for example, then it gets the data from a very basic backup, but this backup might not be the newest version, I would say. So it gets the backup at once from a backup server, and then it gets the missing data from the message broker, and that is how it works. But yeah, that is quite complicated stuff, and it's not finished at all. So we are still working on that.
Okay, thank you.
Okay, so we are just in time. There is 30 minutes left to 4, but yeah, that is quite normal. I left enough space for a lot of your questions, and so I would say feel free to stay, answer questions, or let's do some conversation. It's totally up to you. I would say basically that's it from my side. We talked of all the topics of MicroStream and the fundamental topics of MicroStream, I would say. I hope it was interesting for you. Try it out. As I said, find the right use case for MicroStream in your environments, and yeah, enjoy MicroStream, and thank you for your attention, and stay healthy, and see you then. If you want, you can stay, answer, ask more questions. It's up to you.
Thank you very much, Christian. That was very nice introduction to MicroStreams, and I'm looking forward to the advanced workshop for sure.
Okay, great. See you then. See you there then.
Thank you very much. Have a nice day. Bye-bye.
Bye-bye. See you.
Yeah, thank you very much. Bye.
Christian, thank you also from my side. Unfortunately, I had internet problem most of the days.
Okay.
But you said that there is a recording. It would be published. I guess it would be sent to us.
Definitely.
I mean, a link would be sent to us.
Yeah, definitely.
Okay.
Maybe it's possible to you to access it directly via Zoom. I'm not sure about that, but we will send you the thing, and if not, if something went wrong, just send me a mail. I will take care about that. You will get the recordings.
Okay, your email is c.kuemmel at.
I write it again to the chat.
Yeah. Okay. Thanks. And I have posted a question in the morning. Thanks. Great. I have posted 2 questions in the morning, but I was not able to see if you have answered. You probably have, but I didn't see it.
Yeah, okay.
It was about Micronauts versus Spring.
Okay. Yeah, I could remember. Yeah.
Yeah.
Micronaut versus Spring Boot, right? So
yeah, exactly.
Yeah. I would say there is no versus. It's up to you. MicroStream, Micronaut is the same, it's very similar to Helidon, and Helidon is very similar to Spring Boot, and all these frameworks are microservices frameworks. And I think it's up to you to choose a framework which fits for you. And there is nothing special to do, but especially for Spring Boot, there are some examples within our Git repository. Give me just a second. So I can find the 2 Spring example projects for you. Yeah, it's the same for Quarkus. Quarkus is also a microservice framework. It does the same mostly. So I would say Micronaut is the most popular one. Helidon is right behind it, and also Quarkus. And yeah, you are right. It's quite confusing. There are so many microservice works in place. So okay, so let's see. Spring. Yeah, here it is. So this is the link to the 2 Spring Boot examples. There is one CRUD example with a Spring Boot, and there is also a Spring Boot starter prototype. And if you have any questions, feel free.
Sorry, what was the last one you said? A starter for?
Spring Boot starter prototype is the name of the project itself, but yeah, just try it out. I'm not an expert in Spring, so I'm not able to help, but we have my colleagues will. So if you have any question, ask me, and I will forward that.
Yeah. Okay. But one question would be, when we used Micronauts, we had the launcher, I think it was the name, to
launcher is
to create.
Yeah, that's
create, right. A project. And for Spring Boot, I guess I would have to use their launcher. And
maybe I don't know if there is a launcher in place for that.
Spring, yeah, initializer. I think it's called initializer.
Okay. Yeah, it's the same. So I would say, yeah, but it's there is a different integration for Spring Boot in place, and also for Micronaut. We are working on the Quarkus implementation at the moment. Yeah, but a lot of different frameworks, and I think all did the same.
Okay, thanks.
Basically.
Okay, no more questions.
No more
So
questions.
I will leave. Also,
okay.
Thank you very much for introduction for MicroStream.
Thank you very much.
And I have learned a lot also.
That's great. Enjoy.
Thank you. Yeah,
have a nice week.
Okay.
Nice week.
Thank you. I would leave too. Bye-bye.
Okay, bye-bye.
Yes, I would thank you to you, Christian. Also, lots of learnings now, and I'm look forward to use it in some projects.
Would be great. So
before I go to production.
So tell me your experiences. You got my email address. If there are any problems, call me or write me.
Thanks for support.
Okay. Bye-bye.
Thank you. Bye.
Christian, I have one more question.
Course, yes.
If you are if you are already there.
I'm here.
Yeah. You were using Rapid Clips. I was also using it for a first time. What does it offer actually? Why should I use Rapid Clips and not normal Eclipse or IntelliJ?
So Rapid Clips is specially made for creating a Vaadin UI application.
Exactly. Yeah.
Okay, and Rapid Clips consists of I think the biggest advantage is the Vaadin UI builder. And it's not only a UI builder, it's also combined with the data binding. So you will be able to drag and drop your domain objects, for example, your customers and orders and so on, and create data bindings out of it, fill tables and create forms and stuff like that. And I think Rapid Clips is specially made for Vaadin web applications, to create Vaadin-based web applications.
Yes, but why did you choose to use it? Because
okay.
we didn't use any Vaadin at least in the time where I
that's right. That's a good question. I think the reason is I'm working all the time with Rapid Clips, and to be honest, Rapid Clips is only a standardized Eclipse distribution with some plugins in it, and it works the same for me. And yeah, I got my installations, and yeah, it works for me. And I think that's the biggest advantage for me. Maybe it's quite confusing for you, but I tried IntelliJ a few times, but it's not nothing for me. I tried it, but it's quite hard to get into it for me as a hardcore Eclipse user, I would say.
Yeah.
And I think I'm more productive than with other IDEs with Rapid Clips or /Eclipse, I would say.
Yeah, got it. Okay, thanks.
Okay, no problem. So that I can close the meeting, right? So no more questions.